Welcome to the India's most comprehensive preparation platform, that is the BYJU'S exam prep, and welcome to the Engineering Services Paper 2 analysis. Yes, today 19th of February, ESE Prelims has been successfully conducted for all 4 branches. Okay, the solutions, the answer key, in fact with the proper solutions of paper number 1, जो मॉर्निंग शिफ्ट में होता है, दैट इज ऑलरेडी अवेलेबल ऑन अवर चैनल. वी हैव डन इट ऑलरेडी एंड नाउ me, Sanjay sir, and very soon Saket sir, Ankit Joshi sir, Ashu Jhangra sir, everybody will be joining and will be discussing the solutions and answer key of the paper number 2, that is the technical paper of Electronics and Telecommunication Engineering. And not only for Electronics and Telecommunication, it is running for all branches. So Sanjay sir, over to you. How's the paper? What's the vibration going on?
Already you have given the right now paper is over, and about the technical paper, that is the paper 2. Question is what easy to moderate, and number of questions are what repeated from GATE exam as well as from what previous year question paper of engineering services exam. Okay. Some questions from electrical branch, some questions from what electronics branch. तो जिसने भी previous year question solve किया होगा ना, जो हमने बार बार बोला है engineering services pre के लिए, तो वो आराम से question solve किया होगा. और आप भी अपने views बता सकते हैं यहाँ पर comments box में. और जहां तक मैंने आपको बताया, देखिएगा आप माइक्रो प्रोसेसर के क्वेश्चन देखिए. माइक्रो प्रोसेसर पर 8085 पर लाइन से जो क्वेश्चन आए हैं वो ऑलरेडी कहीं ना कहीं पहले भी आए हुए हैं. स्ट्रेट फॉरवर्ड क्वेश्चन थे, इजी हैं.
एंड सर अभी आई थिंक 2-3 डेज बैक ओनली आपने एक
माइक्रो प्रोसेसर का सेशन लिया, वहां भी आप जाकर देखेंगे तो वैसे ही क्वेश्चन मैंने आप लोगों से बोला था कि ये आएंगे. और जहां बेसिक इलेक्ट्रॉनिक्स पर आप जाइए, सेमीकंडक्टर फिजिक्स पर स्ट्रेट फॉरवर्ड क्वेश्चन है, जहां पर आपको लगेगा थोड़ा मटेरियल और बेसिक सेमीकंडक्टर का. और ऐसे ही हम लोग कभी सभी पेपर्स के एनालिसिस आप लोगों के लिए लेकर आएंगे. राइट, तो पेपर करीब करीब इजी टू मॉडरेट, जैसा एक नेचर होता है इंजीनियरिंग सर्विसेज एग्जाम का वैसा ही है. बट कैलकुलेशन पार्ट था, कैलकुलेशन में अगर आपने सिली मिस्टेक्स अवॉइड किए तो डेफिनेटली आपका पेपर अच्छा गया होगा.
करेक्ट. सो गाइज, बहुत जल्दी हम लोग सारे पेपर का एक वेटेज एनालिसिस, सारे सब्जेक्ट्स का, यू नो स्पेशली यू आर कीन टू नो कि हाउ मच इज एडवांस कम्युनिकेशन, एडवांस इलेक्ट्रॉनिक्स, मटेरियल साइंस, जो एक्स्ट्रा सब्जेक्ट्स होते हैं वो कितना आए, वो आप लोग कीन है. सो वेरी सून विल स्टार्ट डिस्कसिंग द वेटेज एनालिसिस, द डिफिकल्टी लेवल, और जो सब्जेक्ट्स अदर देन गेट है उनका कितना परसेंटेज रहा, सो दैट यू नो दोज विल बी अटेम्प्टिंग द नेक्स्ट ईयर पेपर, दे विल आल्सो गेट एन आइडिया कि कितना एक्स्ट्रा प्रिपरेशन इलेक्ट्रॉनिक्स के लिए जरूरी, बिकॉज 6 सेपरेट सब्जेक्ट्स होता है इलेक्ट्रॉनिक्स के लिए. एंड दैट इज व्हाई you know we always told you कि बाकी भी आपको प्रिपेयर करना है other than gate subject. And before we bring you the complete analysis, पहले कुछ questions, because the first thing students look for is the question. तो कुछ question देखो, EMT एक ऐसा सब्जेक्ट है जिसमें आप लोग थोड़ा सा you know डिविएट करते हो, फियर करते हो, बट वेरी सिंपल ESE एंड इंक्लूडिंग सेवरल पी. इस बार लगता है सर यूपीएससी ने मेहनत कम किया है.
इस बार मुझे ऐसा लग रहा है कि
पीवाई क्यों सर आते हैं, बट इस बार थोड़े ज्यादा लग रहे हैं. राइट,
हाँ, मतलब बहुत सारे, जैसे आप EMFT में भी देखेंगे सर, फॉर्मूला बेस्ड भी है और एज इट इज आप क्वेश्चन पहले भी आए हुए हैं.
बिल्कुल. सो गाइस, दैट इज व्हाट यू नो द पेपर का लेवल है. बहुत ही अभी तक तो सिंपल लग रहा है, बट वी विल ब्रिंग यू द कंप्लीट एनालिसिस वेरी सून. सो स्टार्ट करते हैं सर थोड़े सब्जेक्ट्स के साथ. सो आई एम गाइस स्टार्टिंग विद फ्यू क्वेश्चंस of EMT, then Sanjay sir will have basic electronics. Basic electronics के क्वेश्चन, वो भी सर ने बोला बहुत ही बेसिक लेवल पे ही आए हैं क्वेश्चंस. राइट, सो चलो सीधे क्वेश्चन की तरफ गाड़ी को लेके जाते हैं. जस्ट अ सेकंड. चलो, राइट. So guys, you know, before we spend up any more time spending in typing and all, it's better कि हम लोग जो questions आए हैं, क्वेश्चन पेपर आए हैं, उनके स्क्रीनशॉट पे वर्क करके देखो. ये एकदम फंडामेंटल क्वेश्चन है. आई होप इट इज विजिबल. थोड़ा सा ब्लर हो सकता है क्योंकि फोटोग्राफ्ड इमेजेस हमारे पास आई हैं गिवन बाय आवर स्टूडेंट्स. वेक्टर पोटेंशियल इज अ वेक्टर. नाउ वेक्टर पोटेंशियल की बात हम करते हैं विद रिस्पेक्ट टू मैग्नेटिक फील्ड, बिकॉज इलेक्ट्रिक पोटेंशियल इज द स्केलर क्वांटिटी एंड द मैग्नेटिक वेक्टर पोटेंशियल is decided given by the relation B is equal to the del cross A. Okay, so taking the curl of the magnetic vector potential, we get the B, and that is known as the magnetic flux density. तो इसका आंसर आ गया A. Whose curl? Yes, the curl of A is a magnetic flux density. That is straightforward question. Factual theory question बोलेंगे इसको. चलते हैं अगले क्वेश्चन की तरफ. इसका आंसर हो गया A. चलते हैं डियर अगले क्वेश्चन की तरफ, नंबर 2. Now guys, this is a direct question from Sadiku. This is a direct question from Sadiku, and not only Sadiku, if you have followed my classes, Vision Batch students, this is a classroom question. This is a classroom question. मतलब प्रीवियस वाला तो हर क्लास में होगा क्योंकि वो तो थियरी है, बट दिस इज माय ओन क्लासरूम क्वेश्चन. विजन बैच स्टूडेंट्स कैन चेक आउट द नोट्स. इफ द मैग्नेटिक वेक्टर पोटेंशियल इज गिवन टू यू, व्हाट इज द मैग्नेटिक फ्लक्स क्रॉसिंग? तो देखो अभी पिछले क्वेश्चन में ही हमने बोला दैट बी कैन बी कैलकुलेटेड एज डेल क्रॉस ए. फटाफट से कर लेते हैं इसको. बी कैन बी कैलकुलेटेड एज डेल क्रॉस ए, एंड इफ यू टेक द कर्ल इन द cylindrical coordinate systems, you will have 1 by rho here outside, then you have a rho, rho a phi, a z, del by del rho. Basic calculation है, बहुत basics. Del by del phi and del by del z, and then you have, sorry, okay, and then you have 0, and then the phi component also 0, and then only the z component is there, that is the minus rho square by 4. Okay, and now this is equal to the 1 by rho. A rho agar lenge, so this is del by del phi with respect to rho will be 0, and this is also 0. Directly likhenge minus rho a phi dr, and minus rho a phi del by del rho. If I take minus 2 rho by 4, del by del z of 0 is 0. Az 0 0. Okay, so this is totally now obtained. One of the row will get cancelled, minus minus cancel, total aa gaya rho by 2 a phi, and then the magnetic flux crossing. Guys, you also keep solving if you have learned these subjects. So magnetic flux phi, that is given by actually integral b dot ds. That is actually given by b dot ds, and that is also given by b. हमने निकाल लिया ना, तो b का वैल्यू रख देंगे. What will be the ds? Okay, so b आ गया rho by 2 a phi, right? And along the phi component, the differential surface area can be taken as d rho dz a phi. Okay, along the phi it is d rho dz a phi. So guys, there's a very simple integral in front of you. A rho dot a phi is 1. Rho by 2 ka integral will become rho square by 2, and total ho jayega rho square by 4. D phi integral will be dz integral, sorry. So dz का integral मैंने लिखा, that is equal to z. The limits of z are given to you in that strip. Z is 0 to 5 and rho is equal to 1 से लेके 2. Okay, so ये total answer आ गया 2 square minus 1 square divided by 4 and into 5. So total this 3 into 5, 15 by 4, and that is known as the 3.75 Weber. 3.75 Weber, option number C. Option number C, a direct as it is word to word, data to data classroom question, guys. विजन बैच स्टूडेंट्स आप चेक कर सकते हैं. क्लासरूम क्वेश्चन का ये सीधा सीधा वर्ड टू वर्ड मैच होता हुआ क्वेश्चन है. ओके, सो विल मूव अहेड टू द नेक्स्ट क्वेश्चन. देन नंबर 3, if vector A, vector P is given to you, which of the following statement is correct? Guys, so you can check up na. You can check up. Divergence of P मैंने निकाला. So del by del x of x component 3x square. Del by del y लिया तो 2x square y. Del by del y of the y component तो y square को differentiate किया. Del by del z लेंगे तो x square y constant, z का derivative 1. So this is 3x square minus कितना आया 3x square minus 3x square y, that is not equal to 0. मुझे ऐसा लगता है, I'm just trying to guess that even this questions UPSC has tried to copy it from a previous year gate question, gate 2015 as far as I remember. In 15 this was a question in gate, but gate में केवल एक डेटा और था x cube. I'm trying to guess, maybe उन्हें डेटा intentionally change किया हो, but gate में word to word question था x cube y minus x square y square minus x square y z, and then when you differentiate this ना with respect to x, so you get 3x square y. तो सब कुछ 3x square y minus 3x square y वो 0 हो जाएगा, and there the vector was solenoidal. Name भी same था, vector P. Okay, options भी same थे. That is why I'm trying to guess. Maybe they have copied from gate और यहाँ पे शायद typo error कर दिया, या maybe intentionally change किया. But the data is very same. Gate previous है 2015 around. मेरे को याद आ रहा है. Okay, that is what it is. Now when you talk about the curl, ठीक है, इसका कर्ल निकाल लेंगे. कर्ल में भी बहुत ही फंडामेंटल कैलकुलेशन है, बिकॉज इट इज इन द कार्टेशियन कोऑर्डिनेट. ओके, बिकॉज इट इज इन द कार्टेशियन कोऑर्डिनेट. एंड नाउ द कंपोनेंट्स आर x cube minus x square y square minus x square yz, and this is equal to ax del by del y यहां पे लिया तो minus x square z and del by del z 0. Now guys, minus ay of something plus az of something calculate नहीं करना है ना, because if a vector is 0, all the three components must be 0, and this itself is non-zero. ये कितना आ गया? ये non-zero component दिख रहा है मेरे को. This is minus x square z. Okay, so definitely the curl is not equal to 0. So the vector is not irrotational. It is not solenoidal. So correct answer is C. It is neither solenoidal nor irrotational. It is neither solenoidal nor irrotational. Correct answer is C. Moving ahead to the agla question, that is the fourth. द फोर्थ क्वेश्चन. ओके, लिटिल बिट ब्लर्ड है बट कोई दिक्कत नहीं है, मैं आपको समझा दूंगा इसको. यस, द इलेक्ट्रिक फील्ड ऑन द सरफेस ऑफ अ परफेक्ट कंडक्टर. थोड़ा बहुत तो मुझे लग रहा है स्क्रीन पे दिख रहा होगा, राइट? हार्दिक एक बार यूट्यूब पे चेक करना सही आ रहा है कि नहीं. द स्टूडियो फाइन ना? नहीं, दिस इज ओबीएस, प्लीज चेक इट इन द, है ना? The electric field on the surface of a perfect conductor is 2 volt per meter. The conductor is immersed in water with epsilon equal to 80 epsilon naught. Epsilon equal to 80 epsilon naught. The surface charge density, okay, on the conductor surface, right? D, we all know, is epsilon E, and D itself represents the surface charge density on the surface of conductor given as coulomb per square meter, right? ठीक है. सो अगर हम केवल डी तो वेक्टर फॉर्म में होता है, अगर मैं केवल सरफेस चार्ज डेंसिटी की बात करूं, दैट विल बी गिवन बाय मॉडुलस ऑफ दिस एप्सिलॉन ई, एंड देन इट इज गोइंग टू बी 80 एप्सिलॉन नॉट इनटू द इलेक्ट्रिक फील्ड दैट इज गिवन एज 2 वोल्ट पर मीटर, 160 एप्सिलॉन नॉट, और इट शुड बी 160 इनटू 8.854 10 raised to the power minus 12. सॉल्व कर लेंगे. 1.41 into 10 power minus 9 approximately it is going to come. Answer is D. Answer is D. Clear? Clear है वहां पे हार्दिक, है ना? ठीक है. Guys देखो, you all know that ESE paper is without, ESE Prelims is without calculator. ओके, नाउ अब देखो, ऐसा नहीं कि यहां पे कैलकुलेशन के लिए बहुत ज्यादा परेशान होना है. क्या लॉजिक अप्लाई किया? 160 into 8 point या 160 into 8 or 9, it is going to be in thousands range. It is going to be in thousands range. So definitely 10 power minus 12 will get cancelled with the 1000. So answer should be in the range of 10 power minus 9, 10 power minus 11 तो नहीं हो सकता ना. So you can apply that. Okay, you can apply that. So that is what guys, calculative लगता है, but options save you in the calculations in the ESE prelims. ठीक है, तो ऑप्शंस वही बचा रहे हैं. ठीक है, चलते हैं नेक्स्ट क्वेश्चन की तरफ. दिस वाज द फोर्थ फ्रॉम द EMT. नेक्स्ट है गेट PYQ कॉपी क्वेश्चन ऑफ गेट PYQ. बहुत पहले, आई थिंक 15-20 years बैक पूछा हुआ क्वेश्चन है, बट इट इज अ गेट PYQ वर्ड बाय वर्ड. इफ द इलेक्ट्रिक फील्ड इंटेंसिटी इज गिवन बाय XAX प्लस YAY प्लस ZAZ, देन द पोटेंशियल डिफरेंस बिटवीन X एंड Y. ओके, सो आपको निकालना है VX माइनस VY, और दैट कैन ऑल्सो बी रिटन एज VYX बिकॉज VAB इज VB माइनस VA, एंड नाउ दिस इज इक्वल टू minus integral A to B minus integral V to X E dot dl, right? Okay, so that is going to become E कितना है? That is also equal to the vector R, या अगर मैं इसको expand करके लिखूं डॉट प्रोडक्ट के फॉर्म में, तो it is going to be X dx plus Y dy plus Z dz. Okay, so this is equal to minus of the x square plus y square plus z square divided by 2. Lower limit है मेरे पास y, where the y is 1, 2, 3, and upper limit is x, which is 2, 0, 0. Guys, please do the calculation. Upper minus lower limit, plus 5 volt will be the answer, that is C. Plus 5 volt is going to be the answer, that is equal to the C. Moving ahead to the next question. Okay. नहीं साई रवाली, वाई यू कांट, वाई यू आर सो डीमोटिवेटेड, राइट? मेहनत करोगे. देखो ESE में द ओनली पार्ट इज सिलेबस इज ह्यूज, एंड दैट इज व्हाई यू नीड टू गिव लिटिल बिट मोर टाइम. ठीक है, नाउ कमिंग टू अ एंटीना क्वेश्चन, एक्सपेक्टेड टाइप ऑफ क्वेश्चन. रेडिएशन पैटर्न ऑफ एन एंटीना इन स्फेरिकल कोऑर्डिनेट्स इज गिवन बाय cos power 4 theta, where theta is between 0 to pi/2. Directivity. So first let's find out the directive gain. And that can be calculated as, अच्छा, डायरेक्टिव गेन निकालने के लिए ना मुझे सबसे ये सब छोड़ दीजिए, पहले हम रेडिएटेड पावर निकाल लेंगे. एंड व्हाट इज द रेडिएटेड पावर ऑफ द एंटीना? The power radiated by the antenna will be given by the integral of cos power 8 theta, f square theta, cos power 8 theta into sin theta, u theta, sin theta, d theta, d phi. I'm directly putting in the formulas, right? So this is going to become how much? ओके, इस इंटीग्रल को पहले स्प्लिट कर लेते हैं. cos पावर 8 थीटा इंटू साइन थीटा d theta into integral d phi, where phi nothing is mentioned, so we'll take the complete azimuthal angle, that is 0 से 2 pi, but theta is clearly mentioned 0 से pi/2, and perfect, that is what is the angle I want for the Wallis integral formula. So if I solve this by the Wallis integral formula, तो ये आ जाएगा 8 minus 1, 7 double factorial. So 7 into 5 into 3 into 1, right? Then 1 minus 1, 0, 0 factorial is 1. Divided by m plus n, तो 8 plus 1, 9 हुआ, तो 9 double factorial, that is 9 into 7 into 5 into 3 into 1 is multiplied by pi by 2 if both the powers are even, if one of the power, अगर कुछ भी power odd है तो यहाँ पे 1 multiply करते हैं, then integral d phi is phi upper minus lower limit or 2 pi minus 0. So here 7531 got cancelled. Answer should be the 2 pi by 9. That is known as the radiated power of the antenna. And if the radiated power is now known to me, what is the directive gain? Okay, पहले directive gain निकाल लें हम. So directive gain will become, the directive gain will become cos power 8 theta, that is the radiation intensity, f square theta, divided by the p rad upon 4 pi. Okay, the average radiation intensity, यहाँ लिख देता हूं मैं, average radiation intensity, which is the p rad upon 4 pi. So p rad upon 4 pi will become 2 pi by 9 divided by 4 pi, and that is known as 1 by 18. That is known as 1 by 18. Let me substitute the value there directly. Okay. So this is 1 by 18. So answer is 18 cos power 4 theta, cos power 8 theta. Correct है. So what is the directivity? Directivity is the maximum directive gain. और इसको जब maximize करेंगे तो 18 into 1 answer should be the 18. Because cos theta की, तो अब यहाँ पे 18.02, I don't know किस logic से दिया है, but according to me accurately 18 answer आ जाएगा. ठीक है. So answer is equal to the 18. Correct answer is B. Moving ahead to the next question. Moving ahead to the next question here. Number 7. The directive gain, again a question based on directive gain, but ये थोड़ा सा factual है. The directive gain depends on antenna pattern. Okay, we all know. For the Hertzian dipole, power average, the P average is maximum at theta equal to pi by 2 because Hertzian dipole is broadside antenna. ये भी पता है मुझे. Okay, and it is minimum at 0 or pi, correct. For an isotropic antenna, GD is equal to 1 because isotropic antenna का concept क्या होता है? Isotropic antenna is one which radiates equal power in all direction. Okay, Hertzian power is broadside, matlab it will be radiating maximum perpendicular to the length. Okay, that is why theta equal to pi by 2. Okay, ये अगर एंटीना है तो pi by 2 perpendicular direction में maximum radiation मिलेगा. Okay, the directive gain can be then defined by what? Baba, directive gain is nothing, it is a definition. Even if they don't give you this data, you must know that directive gain is a measure of the concentration of radiated power in one particular direction. How much in a particular direction antenna is able to concentrate the power. Okay, concentrate the power. Total radiated power divided by 4 pi. This is known as the U average. ये तो average radiation intensity का formula है. The ratio of maximum radiation intensity to the average radiation intensity. This is known as the GD max. ये directive gain का नहीं, ये directivity का definition हो गया. Maximum directive gain का. So कई students C में भी confuse हो सकते हैं, but that is the directivity actually. Okay, the ratio of total power divided by the array factor. नहीं, यहाँ पे इसका कोई कोरिलेशन नहीं है. ठीक है, चलो गाइस, तो बढ़िया हो गया 7th क्वेश्चन. नेक्स्ट चलते हैं नंबर 8 की तरफ. कंसिडर अ पैरेलल प्लेट कैपेसिटर. ईच ऑफ द प्लेट्स हैज एन एरिया एंड दे आर सेपरेटेड बाय डिस्टेंस d. Assume that plates 1 and 2 carry charges plus q minus q. Normal conditions are given. Energy stored in the capacitor. Okay guys, you don't have to calculate anything because the energy stored in the capacitor can be directly calculated as half CV square, and then you know that Q is equal to CV, so you can put this as Q by C, and then your answer is directly the Q square by 2C. यहाँ पे कुछ नहीं करना है. It is the correct answer, which is C. Okay, the energy stored is Q square by 2C. That's it. It's a fundamental formula question. Okay, fundamental formula question on the capacitor. Moving ahead to the next question, number 9. ठीक है, ये अच्छा क्वेश्चन है. डाइपोल्स पे हम कैलकुलेट करेंगे. ओके, तो 2 डाइपोल्स, एक काम करते हैं, अगला क्वेश्चन फैक्चुअल है, उसको खत्म करते हैं, फिर डाइपोल पे आते हैं. सो इफ डेल डॉट डी इज इक्वल टू एप्सिलॉन डेल डॉट डी. ओके, डेल डॉट डी एक्चुअली, सॉरी, डेल डॉट डी एक्चुअली इज डेल डॉट एप्सिलॉन ई, राइट, एंड डेल डॉट जे शुड बी एक्चुअली डेल डॉट जे इज इक्वल टू सिग्मा ई. करेक्ट है ना? Okay. Now what they are telling that del dot epsilon is epsilon del dot e. इसका ये मतलब है, right, that epsilon should not be a vector quantity. Okay, and also it should be constant. That is why you have taken outside the differentiation. Del represents what? It's a derivative operator. Okay, so ये बाहर आया है मतलब constant है, and it is not a vector quantity because if it was a vector quantity, vector, okay, you'll have to split it into the product form then. Okay, so what is that judgment? Okay, what is the judgment now? Okay, what is the judgment then? So it is constant, that means it is representing a homogeneous material, and also because the epsilon and the sigma, the epsilon and sigma definitely, especially if I talk about epsilon, it is not a vector, मतलब it is having equal value in all directions, so the material that is being represented is isotropic. तो इसका आंसर होना चाहिए C, isotropic and homogeneous. Isotropic and homogeneous, right? Okay, so moving ahead to the next question, मतलब last question है ये. Okay, 10th question पहले कर लिया. This is the last question for me, guys. So, two dipoles with dipole moments -5 AZ nanocoulomb and 9 AZ nanocoulomb are located at the point 0, 0, -2 and 0, 0, 3 respectively. What is the potential at the origin? What is the potential at the origin? एक simple सा पहले इसका picture बना लेंगे. Okay, so both the dipoles are oriented along the z-axis. Okay, both the dipoles are oriented along the z-axis. Let's say this is your origin 0, 0, 0. Okay, and then the dipoles, जो first वाला है उसकी बात करें, so that is at 0, 0, -2, negative z-axis की तरफ 0, 0, -2, and it is having the dipole moment of -5 AZ nanocoulomb meter. Okay, there is another dipole that is at the 0, 0, 3 positive z-axis, and the dipole moment is 9 AZ nanocoulomb meter. Okay, now what is the potential at the origin? So potential formula due to dipole is actually given by the formula K P dot AR divided by R square, where K is normally 1 upon 4 pi epsilon naught. Free space ही मानेंगे, so 1 upon 4 pi epsilon naught, right? So the value of K directly can be written as 9 into 10 raised to the power 9, putting epsilon naught as 1 upon 36 by 10 power minus 9. Okay, ठीक है. Right, yeah, slightly blurred because it is photographics ना, so मैंने इसलिए question read कर दिया है. Now what is the potential at origin? So dear, the total potential here will be the scalar sum of V1 plus V2. Let's say किसी को भी first, let's say this is your first वाला and this is your second वाला dipole. Okay, so now V1 plus V2 आपको add करना है, एक simple सा calculation complete करना है. AR is the unit vector from the dipole to the point of observation. Okay, so अगर मैं यहां से निकालूं AR1, so from the first dipole to the point of observation, which is the origin, I am moving in the plus z direction, and similarly second वाले से अगर मैं point of observation पे आऊंगा, that will be making my unit vector AR2, and this is in the minus z direction. This in the minus z direction. So dear, अब बात आती है calculations complete करने की, तो ये लीजिए, what should be the V1? V1 will be K, that is 9 into 10 raised to the power 9 into P. पहला है -5 AZ, nanocoulomb है तो 10 power minus 9, dot product with AR, so first is plus AZ direction divided by R. Now R means the distance, so clearly distance कितना दिख रहा है? 2 units का. Okay, so 2 square. Okay, similarly अगर मैं V2 की बात करूंगा, so that is again K 9 into 10 power 9, then P, the dipole moment of the second one is plus 9 AZ, so plus 9 AZ nanocoulomb है तो multiply 10 power minus 9, dot product with the AR, the minus Z direction में है unit vector, and divided by the distance 0, 0, 3 तक है तो distance is 3, तो 3 का square, right? So now clearly 10 power 9 and minus 9 got cancelled. Answer को यहाँ पे finish करेंगे. It should be V1 plus V2. So dear V1 कितना आ रहा है? Okay, it is minus AZ 9 into 5, 45 by. So this should be perfect. जा रहा है ना? Calculation check कर लेना. This is the minus 45 divided by 4 AZ. Okay, sorry, AZ क्यों आएगा? वो तो AZ dot AZ is 1 ना. So only minus 45 divided by 4, and अगला कितना हुआ dear? 9 divided, one of the 9 is getting cancelled, and that is also having the minus component, so minus 9. Okay, so this should be the answer turning up. So ये कितना हो जाएगा? Roughly guess कर लेते हैं ना. 45 by 4, 10, 9, तो 11 plus 9, 20 point something. Okay, तो minus 20.25. कैलकुलेटर को टच करने की नीड नहीं पड़नी चाहिए ESE में, पढ़ भी नहीं रही है. Right, so correct answer according to me is the minus 20.25. ये मार्क कर लीजिए. Okay, minus 20.25. All right, so guys, we have solved 10 questions of the EMFT, 10 questions of EMFT, and now Sanjay sir is there with basic electronics. ये भी क्वेश्चन था EMT का. चलते हैं बेसिक इलेक्ट्रॉनिक्स की तरफ चलते हैं. So which slide number it is? Continuation में. Okay. All right. So guys, as per the official question paper, this is the question number 1112, and this is according to set B.
Set
right.
B.
So that is why guys questions are in front of you. According to set B, it is 112. आपका कोई और set है तो you can just match the language. So sir, over to you. So guys, this is EMT done. I shall come back shortly to discuss another subjects. Thank you.
Rakesh sir.
Thank you sir.
Now we are going to discuss what basic electronics, and very simple question. Directly I'm going to solve some questions. So this is the longest wavelength that can be absorbed by silicon, which has the band gap of 1.12 electron volt is this much. If the longest wavelength that can be absorbed by the another material, then the band gap of this material is approximately. That is what's very simple question already in a GATE exam. That was the question. Yes, repetitive, directly from the previous year question paper. So what is the answer, my dear friend? We have, because this is the 1.12 electron volt. So what is the lambda cutoff? Let this is the constant. Normally we are writing 1.24, but you can take a constant value upon what? EG. That is the band gap. In this way you can find this is the 1.1 micrometer, that is the K upon EG. EG is given as 1.12 electron volt. 1.12 electron volt. So what is the value of the K? 1.1 into 1.12. No need to solve it. That is the value of the K. Then what is that? What is given? If the longest wavelength that can be absorbed by the another material is 0.87, then the band gap of this material is approximately. So again you will write for next one, lambda C2 is equal to what? K, that is the constant, upon EG2. In that case you have to find the EG2. So what is the EG2? K by lambda C2. So what is the K? 1.1 into 1.12, that is the value of the K, upon lambda C2. What is the lambda C2? 0.87. 0.87. So definitely if the lambda decreases, if the lambda cutoff wavelength decreases, means what? Band gap increases. So band gap increases. So which one is higher than that? So this is the lower one. That is not possible. And when we are calculating, so approximately you are going to get what? 1.416. 1.416. No need to use the calculator. Okay. Yes. And that is not possible. 2.854. Just it is what? It is just not decreased by the factor 2 and so on. And that's why it is not increased by the factor 2 or factor 3, because it is inversely proportional to that EG. So hope so. That is the first question. And second one, second question from the basic electronics. 1 minute. Now, okay. The band gap of germanium at room temperature. Again, that is the question based on what? Previous year question paper of electrical branch. So what is the electrical Nirvan, you have given the answer A. So yes. Now what is the band gap of germanium at room temperature? At 0 degree Kelvin the value is 0.785, but we have idea that Eg is equal to 0.785 minus beta T. No need to find the value of the beta and T. We have idea that is nearly equal to what? 0.72 electron volt at room temperature. So 0.7 electron volt, that is the theoretical question. Within 10 seconds we can solve. Right? Yes. Last question. Yes. So that was the question. So this is the answer for this one. That is the set B, question number 113.7 electron volt. Then, okay, this was the answer A. Okay. Next one. Already I have solved. Third question. Again, it is a, what is the answer? Everyone please give me the answer in the comments box. The silicon is doped with the boron. Boron means what? Trivalent. Boron means trivalent. Na. It is given as 4 into 10 to the power 17 atoms per centimeter cube. Assume the intrinsic carrier concentration is Ni. It is a standard value for the silicon. And the value of the Kt by Q, that is nothing but Vt. Vt is given as 25 millivolt at 300 degree Kelvin. The compared to the undoped silicon, the Fermi level of the doped silicon. That similar question in what? In GATE exam already we have solved. Okay, GATE first student, tell me what is the answer. Same question in GATE exam. Directly you can put the answer here, right? And now if we are giving the Na type doping, it will become P type. When we are giving the Na means acceptor type, it will accept one electron, it will create hole. This is the P type. Then this is the EC, this is EV, and this is the intrinsic Fermi level. And then for P type, it will become, this is the EF. Okay, so it is goes down. So which answer goes down by? This is correct, this may be correct, and this is wrong. This is wrong, goes down. And now goes down by means what is this? Kt log of kT log of Na by Ni. That is the formula. This goes down by this value. So what is the kT? 0.025 log of Na. What is the Na? 4 into 10 raised to power 17 and divided by what? 1.5 into 10 raised to power 10. And that is the value. Then it is a standard question. Then directly you can give the value. That is, it goes down by what? 0.427 electron volt. Now you can calculate it. Now you can calculate it. So what is the answer? Yes, everyone. आप लोगों का क्या है एग्जाम में, जरा कमेंट्स में तो बताइए जरा. तो ये चेक कर लीजिएगा. दैट इज द कैलकुलेशन. और ये आपका इतने से डाउन हो गया. अब आप इस क्वेश्चन को देखिए. सेम क्वेश्चन इन गेट एग्जाम. ओके, नाउ नेक्स्ट वन. ओके, अब आते हैं अगले क्वेश्चन में. Resistivity of a uniformly doped type N-type silicon is 0.5 if it is N-type. So what is finally what is asked? Donor impurity concentration. What is the donor impurity concentration that is asked here? Okay, Nd is asked. Why Nd is asked? Because it is N-type. It is given here. Resistivity is given. Electron mobility is given. We have the sigma. Sigma is what is the 1 by rho, and that is given by NQ mu n. For N type, what is the N? Nd. You have to find the Nd. So what is the N is equal to? Nd is equal to 1 by rho Q mu n. Now, what is the rho is given? 0.5. What is the Q? 1.6 into 10 raised to power minus 19. And mobility is given as 1250. Calculator is not required. Calculator not required. Directly you can solve. 1250 coulombs. The donor impurity concentration in the sample is. My dear friend, you can put it is 1 by 2. So that will become 0.8. 0.8 multiplied with the 1250, you will get the 1000. Okay. So it is the 1000 into 10 raised to power minus 19. Then it will become 10 to the power what? 16 per centimeter cube. No need to use the calculator. Okay. So this is the 0.8. 0.8 into 1250. It is nothing but 1000. Okay. So this is the 1 into 10 raised to power 16. तो ये तो बना होगा भाई. क्वेश्चन बड़ा इजी है. Right? Next one. Next question. This is about the 115 now. Okay. अब आते हैं अगले में. फिर से देखिए वही बार बार सेमीकंडक्टर फिजिक्स पर है. स्ट्रेट फॉरवर्ड क्वेश्चन. Silicon sample A is doped with the 10 to the power 18 atoms. देखो कई लोगों को ये कंफ्यूजन होगा कि सर दिस इज द क्वेश्चन फ्रॉम मटेरियल साइंस और दैट इज द क्वेश्चन फ्रॉम व्हाट बेसिक इलेक्ट्रॉनिक्स. Yet there is the overlapping syllabus, right? In engineering services exam we have to solve the question because we have the semiconductor physics in what basic electronics, we have the semiconductor physics basics of semiconductor physics in material science also. Now silicon sample A is doped with 10 to the power 18 atoms per centimeter cube of the boron. Again boron means what? P-type means what? Acceptor. Another sample B of the identical dimension is doped with the 10 to the power 18 atoms per centimeter cube of phosphorus. Phosphorus means pentavalent. Boron means trivalent. Okay. The ratio of the electron to hole mobility is 3. The ratio of the conductivity of the sample A to that of the sample B. आपको कुछ याद आता है? इसी तरीके का क्वेश्चन हमने गेट में भी सॉल्व किया था. सेम टाइप सिमिलर क्वेश्चन. डायरेक्टली आप तो 1/3 मार्क कर सकते हैं, लेकिन फिर भी अगर आप पहला जो मटेरियल है दैट इज द बोरॉन. बोरॉन मींस पी टाइप. तो व्हाट इज द कंडक्टिविटी फॉर द पी टाइप? द कंडक्टिविटी फॉर द पी टाइप इज सिग्मा. इट इज गिवन बाय पी क्यू म्यू पी. एंड द कंडक्टिविटी फॉर द इलेक्ट्रॉन is given by NQ mu n. Since P is equal to Na is equal to 10 to the power 18 and N is equal to Nd is equal to 10 to the power 18. Similar, same concentration of donor and acceptor. What is the ratio? Sigma P by sigma N, conductivity of A material, and this is the A material and this is the B material. It will become P by N. P's cancel out. Okay. Mu P by mu N. And what is the ratio of the mu P by mu N? The ratio of the electron to hole mobility is 3. So that will become 1/3. And that's why the answer is what? B. So read question carefully. That is given the ratio of the conductivity of the sample A to that of the B. That is asked in the question. I think now it is clear. अरे जरा आप लोग थोड़ा कमेंट्स में एक्टिव रहिए भाई, क्या हो रहा है. चलिए अब आते हैं नेक्स्ट क्वेश्चन पर. नेक्स्ट वन. According to Einstein relation for any semiconductor, the ratio of the diffusion constant to mobility of the carrier. So diffusion constant and coefficient, as you know that value is what? dP by mu p, Einstein equation, is equal to dN by mu n is equal to what? Vt, volt equivalent of temperature. And what is the Vt? That is nothing but kT by Q. K is the Boltzmann constant and Q is the charge. So it will become T by 11,600. Means this ratio is directly proportional to what? Temperature. So depends upon the temperature of the semiconductor. Depends upon the temperature of the semiconductor. So according to Einstein relation. देखो ये बाकी पढ़ने की जरूरत है. Depends upon the type of the semiconductor. Varies is the lifetime semiconductor, increases the velocity of the charge. That is the Einstein equation here. Next it is asked. I think now up to this point it is clear. Next one. Heavily doped n-type semiconductor. Again heavily doped n-type. Heavily doped n-type written means N is equal to Nd. Has the following characteristics. Whole electron mobility ratio. Again similar type of question. Mu n by mu p is equal to what? 0.4 in a previous question. Doping concentration Nd is given as 4.2 into 10 raised to power 8 per meter cube. Please read the unit, atoms per meter cube. Normally in semiconductor we are having the unit what? Atoms per centimeter cube, but it is a meter cube. Intrinsic concentration 1.5 into 10 raised to power 4 atoms per meter cube. It is not in centimeter cube. The ratio of the conductance of n-type semiconductor to that of intrinsic semiconductor of same material and at the same temperature is given by. So what is the ratio? Ratio of the conductance of the n-type semiconductor. Conductance n-type semiconductor is given by, what is the conductivity? NQ mu n. And for intrinsic semiconductor, what will be the conductivity? NQ mu n plus PQ mu p. PQ mu p. Because it is the intrinsic type, that's why it will become NiQ is common, mu n plus mu p. N is equal to P is equal to what? Ni. That is intrinsic semiconductor. Okay. Now divide these two. This is extrinsic, this is intrinsic. So sigma E extrinsic, sigma E intrinsic. Right, this will become QQ cancel out. Okay, N is nothing but Nd mu n divided by Ni mu n plus mu p. Now Nd is given. What is the Nd? 4.2 into 10 raised to power 8 upon Ni 1.5 into 10 raised to power 4 per meter cube. Now mu n, divide it. 1 plus mu p by mu n. Mu p by mu n. And what is the mu p by mu n is given as 0.4. Mu p by mu n is given as 0.4. So it will become 1.4. So this calculation is very easy. 4.2 into 10 raised to power 8 divided by 1.5 into 10 raised to power 4 into what? 1.4. This is 3 and that is 2. And 2 into 10 to the power 4. 2 into 10 to the power 4. That is the answer. So which answer is correct? 2 into 10 to the power 4 means 20 into 10 to the power 3. That is the answer. 20 into 10 to the power 3. That will be the answer for this question. Okay. Now, next one. So again, that is no need to use the calculator. No need to use the calculator. Directly you can solve it. Similar type of questions. Next one. Okay. Silicon bar is doped with the donor impurity Nd 2.25 into 10 raised to power 15 atoms per centimeter cube. Again, it is in a centimeter cube. Given the intrinsic carrier concentration of silicon 1.5 into 10 raised to power 10 assuming the complete impurity ionization, the equilibrium electron and hole concentration are respectively. Okay, तो देखिए एक मैसेज भी है जिन स्टूडेंट्स ने इस एग्जाम को देने नहीं गया, देखिए क्वेश्चन का लेवल देखो, आपको एक बार अटेम्प्ट करने जरूर जाना था. आफ्टर प्री देयर विल बी व्हाट मेंस एग्जाम, राइट. तो अभी बहुत सारे और भी एग्जाम होंगे, इसरो भी है आगे आपका, सॉरी बार का भी एग्जाम आने वाला है, इसरो का भी नोटिफिकेशन आ जाएगा, तो ये आपकी हेल्प करेंगे क्वेश्चंस कुछ, बट ये सीधा स्ट्रेट फॉरवर्ड क्वेश्चंस हैं. अब देखो, सिलिकॉन बार इज डोप्ड विद द डोनर इंप्योरिटी Nd, इट इज गिवन, इंट्रिंसिक कैरियर कंसंट्रेशन इज गिवन. Assuming complete impurity ionization means 100% ionization of Nd. The equilibrium electron and hole concentration are respectively. तो एक बात बताइए, जब when we are giving the Nd type of doping, तो what is the concentration of electron? It is nearly equal to Nd. It is nearly equal to Nd. And that's why N is equal to Nd is equal to 2.25 into 10 raised to power 15. 2.25 and 10 to the power 15. And what is the concentration of hole then? According to mass action law, it will become Ni square by N. So that is 1.5 into 10 raised to power 10 upon what? 2.25 into 10 raised to power 15. It will become 2.25 into 10 raised to power 20 divided by this value. Okay, so what is the answer? 10 to the power 15, 10 to the power 5. 10 to the power 5. Okay, next question. So 2.25, I think that this is last D option. यहाँ पे आपको दिख नहीं रहा है, लेकिन ये जो आपको दिया हुआ है, this is what is the concentration of hole here? 10 to the power 5 per centimeter cube. This is the D option. Okay, next one. अब आते हैं हम अगले क्वेश्चन में. अगेन दिस इज द बिल्ट इन पोटेंशियल. व्हाट इज द फॉर्मूला? गिव मी द आंसर इन कमेंट्स बॉक्स. इन एन ओपन सर्किट स्टेप ग्रेडेड जंक्शन, द लेफ्ट हाफ ऑफ द बार इज पी टाइप. This is P type, this is N type. Here we are giving the Na doping, here we are giving the Nd doping. This is the step graded semiconductor material, right? Suddenly the concentration will decrease. For step graded semiconductor, here we are giving Na type doping, here we are giving the Nd type doping, right? And there will be the built-in potential. So what is the formula for built-in potential? Constant concentration, whereas right half is the N type with uniform density. In this type of doping, the density changes abruptly from P type to N type. What is the contact difference of the potential, or that is called built-in potential? Formula based question, Vt log of Na by Ni square. Vt log of Na by Ni square, and that is the formula for built-in potential. Okay. अब यहां देखो जूल में दिया हुआ है, ये ऑप्शन मैच नहीं हो रहा है, ये ऑप्शन मैच नहीं हो रहा है, और ये ऑप्शन आपका मैच हो गया. नेक्स्ट क्वेश्चन. ओके, तो अब यहां तक हो गया, और भी मैं आप लोगों के लिए क्वेश्चन लेकर आऊंगा, दैट इज फ्रॉम द एनालॉग एंड अदर सब्जेक्ट, दैट इज अगेन राइट. तो अब आपके लिए साकेत सर आ रहे हैं. सर विच सब्जेक्ट? कम्युनिकेशन. क्वेश्चंस फ्रॉम व्हाट? कम्युनिकेशन. तो वेलकम साकेत सर.
Hello, good evening everyone. So I hope that you guys have done well in the ESE exam. That is very basic exam. Actually the exam is good, but the questions are very basic, and it is very good for practicing that particular revision purpose, you can say. And many of you have given this exam seriously. So let's discuss with the first question. So what is the answer of this question? Tell me the frequency range for the broadcast satellite services. So that is the direct question that we generally work in the X band, and the range that is, sorry, here we have satellite communication, right? So for satellite communication we use which frequency? That is 4 to 8 gigahertz. That is the direct question, because we have number of frequency band, that is L, S, C, X, Ku, K, K, and X band is used for microwave communication. So 4 to 8, because we know that the uplink frequency is 4 and the downlink frequency is 6 gigahertz. So that is the correct answer. That is option B. Okay. So now this is, we have the second question. an angle modulated signal is given as XCT is equal to 20 cos 200 pi t plus pi by 4. What is the instantaneous frequency? What is the instantaneous frequency you have got? So it is very easy. Direct formula based question, that is Fi is equal to Fc plus 1 upon 2 pi and d phi by dt. Okay, so this is the formula we have. Yes, Anirban, what is the answer of this question? So Fc, we have the carrier frequency which is 100 and plus 1 upon 2 pi d by dt of phi. What is phi? The value of phi is pi by 4. So it is independent of time. So when you differentiate it, it will become 0. So the correct answer would be 100 Hertz. So the correct answer would be 100 Hertz for this question. Right? Yes, Anirban, option B is the right answer. Now the next question is, an FM modulator operates at carrier frequency of 250 kHz with the frequency deviation sensitivity of 1.5 kHz per volt. A PM signal operates at 500 kHz and its phase deviation sensitivity is 1.5. If both PM and FM are modulated by the same modulating signal having the peak amplitude 5 volt and 5 kHz, then what is the relationship or between the frequency modulation index of PM and FM? So what is the answer of this question, guys? Come on, answer this question. So we know that if I directly calculate the modulation index for FM, we know that this is nothing but a maximum frequency deviation divided by message signal frequency. So it is KF into AM upon FM, right? So what is the value of KF? The KF is given as 1.5 and the message signal amplitude is 5. FM is also 5. So we have got 1.5. Okay, what is the modulation index for PM? That is your KP into AM. What is the value of KP? This is 1.5. The amplitude of message signal is 5. So it is equal to 7.5. So what should be the correct answer for this? The PM signal is equivalent to 5 times of FM. So answer is option D. So answer is option D. Got it? Answer is option D. Next. Now, an audio signal S of t is equal to 5 cos 2000 pi t is quantized using 10-bit PCM. What is the signal to quantization noise ratio? As you can see that this is the sinusoidal signal. For the sinusoidal signal, what should be your signal to quantization noise ratio? So signal to quantization noise ratio for sinusoidal signal is given as 3 by 2 into L square. Okay, direct formula we are using. So 3 by 2 L square, or this we can also write, because L is the number of quantization level. So we can write 2 to the power 2n also. So this is nothing but 3 upon 2 into 2 to the power 2 into number of bits required is 10. So the answer is 1.57, I think. 1.57. According to the calculation, it should be 1.57. Let me check where I have done the calculation. Yeah, so option C is correct. 1.57 into 10 to the power 6. Okay, so this you have got, yes, 1.57 into 10 to the power 7, right? So let's take next question. So already the answer is marked over here. Is it correct or not, Ayush? Ayush, Anirban, this answer is correct or not? An FM audio signal with the single tone modulation has a frequency deviation 25 and the bandwidth is 75. So what is the message signal frequency by the Carson rule? So by the Carson rule, we know that the bandwidth is given as 2 times of maximum frequency deviation plus message signal frequency. The bandwidth is 75. It is 2 times 25 plus FM. So even when you will solve it, this is 37.5. 37.5 minus 25 is 12.5 kilohertz. So correct answer is option A. Right? Next question. Question number 54. So by considering the standard notation of the normalized power, what is the power of AM? So let's take S of t. This is S of t is equal to what? AC 1 plus k into mt cos omega ct. So if I calculate the power, that power is nothing but a AC square by 2 plus AC square k square, and this is the mean square value of message signal. If I assume that the message signal has the mean value 0, so this is nothing but a mean square value. So if I take the k is equal to 1, it will be AC square by 2 and AC square m square t bar divided by 2. So according to option, if I go, so this is actually wanted to say the mean square value of message signal. So correct answer according to the option is option A. Yes. So next is, now a certain AM transmitter is modulating 125 kilowatt when a certain audio sine wave is modulating it to be depth of 70% and 144.5 kilowatt when a second sinusoidal audio wave also modulates. Then we have to calculate the modulation index for the second wave. So as you can see that this is the total power which is given 125 kilowatt, and that time we have the modulation index as modulation index 1, let us say this is 70%, right? And the next power is given as 144.5 and modulation index in the second case we want to calculate. So from here we will calculate the carrier power, that is PT PC 1 plus MA1 square divided by 2. So if I calculate the carrier power from here, this is nothing but a PT upon 1 plus MA1 square divided by 2. So if I solve it, this is 125 into 10 raised to power 3 divided by 1 plus 0.7 square divided by 2. What is the carrier power you are getting? What is the carrier power you are getting? So carrier power we are getting as 100.4 kilowatt. Okay, 100.4 kilowatt we are getting. Right now, we want to calculate the total power in the second case. So this is PT dash we have written. So it is PC 1 plus MA total square divided by 2. So if I substitute the value of PA dash, which is 144.5, and the PC we have 100.4, 1 plus MA total square divided by 2. So from here we will get MA total square is equal to 0.878, and we know that MA total square is equal to MA1 square plus MA2 square. So from here if I calculate the MA2, which is root over MA total square minus MA1 square, so this is a bit lengthy question and the answer is coming as 0.4. Okay, so the MA total square you have 0.878 and MA1 is 0.7. So square it and then subtract it, you will get 0.388, which can be approximated as 0.4. So the answer is option A. So coming to the next question. So this is the question from EMFT, right? EMFT. So there are few questions which are repeated and you can directly mark this answer, right? Because this is the previous year gate question. There is no need of any calculation over this if you remember that particular question directly. So here you can see that the beta is given as 25 and for free space it is omega by c. So you can calculate as 25 into c divided by 2 pi. So this is 25 into 3 into 10 to the power 8 divided by 2 pi. So when we calculate it, we get F is equal to 1.2 gigahertz. Okay, this is a direct question and we want to calculate the polarization. So if we go from the lead and lag concept, so this wave is traveling in the positive x direction. So the wave is propagating in the positive x direction. This is y, this is z. The phase of z is here, it is written j, that means it is 90 degree. So here it is leading, the phase of z is leading, and the phase of y is 0, so which is lagging. So we move from lead to lag. Okay, so we move from lead to lag, and because the amplitude is equal and the phase is multiple of pi by 2, odd multiple of pi by 2, so we can say this as a circular polarization. And because it is satisfying by the left hand, because you can see that the thumb should point in the direction of propagation and finger should be in the direction of this tip of the trace of the tip of electric field. So this is nothing but a left hand circular polarization. So correct answer will be option B. Yes, so correct answer is option B. Now coming to the next one, let me see. Okay, so this is done. Yes, so this question we can directly solve by the wave equation. Okay, so the wave equation, we know that this is d square E upon dt square minus Vp square d square E upon dz square equal to 0. So for a wave to be electromagnetic wave, we should satisfy this particular equation. So this is quite lengthy question, you can say. You have to cross check this particular equation for all the option. So if I check, then I see that this answer is option D. So I am writing this directly. You have to just put the value of electric field or the wave equation in this particular equation, and you have to satisfy this particular equation. Okay, yes. Next question. Yeah, so the intrinsic impedance of a copper at high frequency. So intrinsic impedance of a copper at high frequency. Copper is nothing but a good conductor. So in the good conductor, the eta is given as omega mu upon sigma at an angle of 45 degree, which can also be written as 1 plus j divided by sigma into delta. Okay, if I convert this particular equation in this form, in the Cartesian form, or then you will get this 1 plus j upon sigma delta. So what should be the correct answer according to this? Here you can see that this is nothing but a reactive part is positive and the resistive part. So this is behavior of inductive component. So the complex with an inductive component. Coming to the next question. Question number 70. It is not. So the question is like the depth of penetration of a wave in a lossy dielectric increases with increasing. So what we should increase to increase the depth, skin depth or depth of penetration. So we know that this for low loss, okay, I am approximating it for the low loss. For low loss dielectric, it is nothing but a sigma by 2 root over mu by epsilon. So here the skin depth is given as 1 upon alpha. So when you will write, this will become 2 upon sigma root over epsilon upon mu. So if I increase the permittivity, then the skin depth will also increase. So what we want to increase the depth of penetration. So to increase the depth of penetration, we have to increase the permittivity. So the answer should be option D. Okay. So there is another question from EMFT, that is the transmission line question, and it is again the previous year gate question. So there are multiple previous year gate questions. Okay, the range of the S parameter, that is also directly from the previous year gate question, and the remaining question that we have solved just now, that is also from the previous year gate. So it is distortionless transmission line. So for the distortionless, okay, for the distortionless transmission line, we know that this R by G is equal to L by C. This is the condition, and the alpha is nothing but a root over RG. Okay, and the characteristic impedance is nothing but a root over R by G. The alpha is we want to calculate, and the Z0 is given. Okay, The Z0 is given. So let's multiply these two equations. This is equation number 1 and 2. So if we multiply, this is alpha into Z0 is equal to R, and we want to calculate alpha. So alpha is equal to R upon Z0, and the value of R is given 0.1, and the Z0 is also given, which is 50. So this is 0.002. That is your option number D. Okay. So I think this is done. Yes. So this is the question from your subject. No, sir. So now the Murli sir is coming to tell you about the computer organization. Okay. Over to you.
Hello guys, I will be teaching computer organization architecture. So few questions of computer organization and architecture we are going to discuss, which are asked in the today's examination. So this is the question number 40. Question number 40. So what is the overall number of clock cycles per instruction? That is a CPI. CPI is nothing but cycles per instruction. So we need to find out overall number of cycles per instruction for a machine A, for which the following performance measures were recorded when executing a set of benchmark programs. Assume the clock rate of CPU is 200 megahertz and execution of 100 instructions are considered. Okay, so we are supposed to execute 100 instructions here, and the category of instructions are given. So ALU indicates arithmetic logic unit related instructions, and load and store instructions, branch instructions, and other instructions. And this is the percentage of occurrence of these instructions in the respective type of instructions, and the number of cycles per instruction taken is also given. So what is that we are supposed to find out here? Performance measure. Okay, and overall when executing these instructions, okay, so the overall number of clock cycles you have to find out. Okay, so there are 38% of instructions are ALU instruction. So 38% is nothing but here, so 0.38. So 0.38 into how many cycles are taken? 1 cycle is taken, and the ALU instructions are finished. Now coming to load and store instruction, 15%. 15% means 0.15. So 0.15, how many cycles it is taking? 3 cycles. And we are having 2 more type of instructions, branch instructions. So branch instruction is taking 42%. So 0.42 into 4 cycles. Okay, 4 cycles plus the last category, there is other instructions, that is 5. The percentage of instruction is 5. 5% means 0.05 into the number of clock cycles taken is 5 cycles. So the total performance would be, anyway we are finding the number of cycles. If you multiply with this cycle time, you will get 100 instructions now. So you can multiply with 100 and you can divide with 100. So here it would be 0.38 plus 0.45 plus this is 1.28 plus 0.25. Okay, the sum of all these will be 2.76. So it is 2.76. 2.76 is the average. So option A is the right option. So this is option A. And let's move on to the next question. Okay. Now coming to question number 41. What is the number of bits in the main memory address for a memory system having the following specifications? So there are some specifications given here. So size of the main memory is given as 4K blocks, and size of the cache is given as 128 blocks, and the block size is 16 words. And assume that the system uses set associative mapping with 4 blocks per set. Okay. Now what is that question they are asking? The question is number of address bits for memory. So memory is a word addressable here because the block size is given is a number of words. Okay. So for instance, if I take a the total memory size, so actually the memory is containing 4K blocks. 4K blocks. So 4K blocks is nothing but it is a 2 power 12 blocks. There are 2 power 12 blocks. How can you say there are 2 power 12 blocks? 1K can be written as 2 power 10. 1K is nothing but 1024. Okay, so 1024 is nothing but 2 power 10. Okay, so here 2 power 10 into 2 power 2, 4K is nothing but 2 power 2. There are 2 power 12 blocks in the memory. And also each block is of how many words? There are 16 words in a block. Okay, so 16 words nothing but 2 power 4. So 2 power 12 into 16 words. So to identify one word out of these many words, we have to write this address in the form of powers of 2. So this would be 2 power 12 into 2 power 4. So this is nothing but it is a 2 power 16 words. So to identify one word out of 2 power 16 words, we require 16 bits. Actually, just for confusion, they have given the cache memory size and associativity, but here straight away we have to find out the number of bits required for addressing the main memory word. Okay, so main memory is given in the form of number of blocks and block size is given. So the right answer for this is option D. Now let's move on to the next question. Okay, now coming to question number 42. Consider the following reference string of pages made by the processor. These are the reference string. Assume that the number of page frames allocated in the main memory is 4, and what is the number of page faults generated using the least recently used replacement algorithm. So what do you mean by least recently used? Least recently used means the page that has not been used from the longest period of time, that is a victim page to be replaced. Okay, so if you see the pages available, whatever the page available in the main memory that has not been used from the longest period of time, that is a page to be replaced. That is considered to be a victim page. Okay, now coming to as for the given data, we are having the 4 page frames. Okay, so we are having the 4 page frames. So initially 4 page frames are empty. Okay, so what is the first reference string actually? Page number 4. So we can keep the page number 4 here. So that is a page fault. What do you mean by page fault? If the referenced page is not available in the memory, we are supposed to get it from the disk. So for that it requires a paging hardware to access. So that means we require to transfer the page. So for that there is a page fault. If the referred page is available in the main memory, that particular page reference is considered to be a hit. Okay, if it is a miss, that is considered as a page fault because we are supposed to bring it from the disk. Okay, now coming to the one page fault is there, next 7 is there. Okay, 7 is also one page fault. Again 5. So 4, 7, 5. In the third frame it is inserted. Again 7, there is a hit. So this is a page fault. I am keeping a tick mark for a fault. At the time of reference it is not available, but at the time of reference 7th page is available, so this is not a fault. So this is a hit. Okay, so because 7th page is available, then for a 6th page it is not available, so it is a fault. So we can keep the 6th page in the 4th frame. Now as of now 4 faults are occurred. Now coming to the next 7 is a hit, so that means it is available here. And what about 10? 10 is a miss. So out of these 4 pages, which page will be replaced? That is the criteria here. Okay, the page that has not been used from the longest period of time is a victim page to be replaced. Okay, so which page is not being used from the longest period of time? From the 10th page. So 7th page most recently used, and 6th page next most. 7th page is already there. 5, 4. From the long time there were no references for 4. 4 is considered to be a victim page. So now 4 is replaced and 10 is inserted. So 10, 7, 5, 6. Okay, na? So this is also a fault. Now there is a 4. 4 is also not available. Just now we have replaced as a victim page. Now in order to provide a room for the page number 4, we have to replace one of the existing page. So which page can be replaced? Either 10 or 7 or 5 or 6. We have to choose it. Okay. So 10 is the most recently used. 7 is the next most. 6 is the next most, and 5 is the least. So 5 is the victim page. 5 to be replaced, and we have to insert 4. And remaining pages are as it is. Okay, na? Now as of now we got 1, 2, 3, 4, 5, 6 faults are there. Now page number 8 is also not visible here, so that we have to replace it, some of the existing page. For providing a room for a page number 8 which is to be replaced, okay, and 4 is the most recently used, 10 is the next most, and 7 is the next most, and 6, okay, 4, 10, 7, 6. So from long time there were no references for page number 6, so we have to replace the page number 6. So 8 is inserted here, so 4, 7 and 10, right? Now there is a 5 is also fault because right now it is not available. 5 is also fault, just like 8. Okay, now 8 is most recently used for providing a room for 5, and next most recently used is 4, and next most recently used is 10, next is 7. So 7 is the least. So 7 is the page that replaced. So that means we have to replace 7 and insert 5. Okay, like this. Okay, now we are having fault here for 5. Now there is a page number 8, there is no fault because it is already available. Page number 6, what is to be replaced? 8 most recently used, 5 next most, 4, 10 to be replaced. Okay, 6, 5, 4 and 8. So the 6 is also fault. Okay, now coming to 8 is available, that is not a fault. Okay, now coming to 11 is a fault, it is not available. What can be replaced? 8, and next most is 6, next most is 5, and 4 is the victim page here. So 4 is to be replaced to provide a room for 11. So it is a 6, 5, 11 and 8. Okay, then what is the next? This is a hit fault, right? Now 4 is not available. What can be replaced? 11 is the most recently used, next is 8, and next is 6, and 5 is to be replaced. So in the place of 5, 4 will be inserted, 11 and 8, and 4 is also a fault. So long reference string is given. Okay, now coming to the 9, so what can be replaced? So 4 is most recently used, 11 is next most, and 8 is next most, 6 is the least. So 6 can be replaced. So it is a 9, 4, 11 and 8. Okay, so 9 is also fault. Next to 5, what can be replaced? 9, 4, 11, and we can replace 8. 8 is the least. So for a 5 we have to replace 8. So it is a 5 and 11, 4 and 9. I hope you understood. Okay, now coming to 9, it is not a fault because it is already available. Okay, 6 is a fault. What can be replaced? 9 is the most recently used before 6, and 5 is the next most. Okay, and what is next? 4, 11. 11 we can replace. Okay, so 6, this is 5, and this is 4, and this is 9. Okay, so 9 is also, we provide a room for 6 also. Now coming to 9 is a hit, it is available. And coming to 12, so 9, 6, 4, 8. So 8 is from long time there is no references. So that means 8 can be replaced here. So what is that pages available? This is not 8, sorry, this is 5. Okay, so we are providing a room for 12, right? So 9 we can't replace, 6 we can't replace, 5 we can't replace, 4 we can replace. So 4 can be selected. This is not 8, this is 5. Okay, so 4 is selected as a victim page. Okay, now coming to 4. Okay, 9, 12, 6, 5. What can be replaced? So 12 is most recent, next 9 is next most, 6 is next, and 5 is least. From long time there were no references for 5. So 4, 6, 12 and 9. I'm just bifurcating these two, and then 4 is the fault here. Okay, now coming to 7. Okay, and 4 most recent, 12 next most, and 6 is the least. So 7, this is 4, 12 and 9. Okay, now that is also one fault. Next to 5 and 7. So for 5 what can be replaced? 7 we can't replace, 4 we can't replace, 12 we can't replace, 9 we can replace. So we can get 5, 12, 7 and 4, and this is the page fault. 7 is a fault, not a fault because it is already available. So how many faults are there total? We can see the tick marks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 faults are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. total 18 faults. Option C is the right option. So this is the question number 42. Now let's move on to the next question. Yeah, question number 43. Okay, fine. So 43 is related to operating system. That is, of course, in the computer architecture only is a part of that. And which one of the following is correct with respect to short-term scheduling? The first one is the decision as to which available process will be executed by the processor, and option B, the decision as to which process pending IO request shall be handled by an available IO device, and option C, the decision to add to the pool of process to be executed, and option D, the decision to add to the number of process that are partially or fully in main memory. So short-term scheduling and long-term scheduling, there are two schedulers. So long-term scheduler will select the jobs from the pool of jobs, okay, and short-term scheduling, what it does is it will schedule the CPU among the available jobs in the main memory. For what job we have to give the CPU, that will be decided by the short-term scheduler. This is also called as the CPU scheduler. The task of short-term scheduler is the decision as to which available process will be executed by the processor. That means, let us suppose if you take a main memory, the process that are ready for execution are maintained in the main memory in the form of a queue. Let us suppose job 1, job 2, job 3, they are ready. They are ready means at any moment we may assign the CPU to one of these jobs so that those jobs can be executed. So out of the available jobs, so what job is to be taken first? That depends on the scheduler, short-term scheduler. So that's what the option A says. The decision as to which available process will be executed by the processor, that decision is taken by the short-term. That's it. So remaining all are related to IO scheduling and other things. Okay, IO schedulers and also long-term schedulers, etc. Now let's move on to the next question. Yes. So question number 44. Which one of the following statements is correct with respect to the bounded buffer in a shared memory system? Okay. So what do you mean by a bounded buffer problem? Actually, this is also called as the producer consumer problem. So actually bounded buffer means the practical limit will be there for the size of the buffer. Okay. So there will be two processes, that is the producer process and also consumer process. Producer process will add the items to the buffer and consumer process will remove the items from the buffer. So we maintain a counter. Counter is a common variable in the producer consumer problem, and when the item is added to the producer, the buffer, common buffer, the counter value will be incremented. When the consumer has taken out some value, then consumer will be decrementing the counter. So that is what the criteria. So in this counting value, actually when the producer is keep on adding the items, if a buffer is full and consumer has not consumed any item, the producer will be stopped. In case if all the items are consumed by the consumer, then the buffer is empty, there is no item to consume, then the consumer will be stopped. That is a bounded buffer problem. If it is unbounded, if only consumer can be stopped if item is not there, but producer can never be stopped, always it will have some empty location to produce. So as it is a bounded buffer problem, as per the given options, the consumer may have to wait for new items, but the producer can always produce new items. That means this is for unbounded buffer. This is not correct. And option B, the consumer must wait if the buffer is empty. If there is no item, then consumer cannot take, it will stop and waiting for the item. And the producer must wait if the buffer is full because some empty location is required for adding the item. So option B is correct for a bounded buffer problem. And why option C and D are wrong, I will show you. The producer and consumer must be synchronized so that the consumer does not try to consume an item. No. We are not supposed to allow the consumer to stop. Okay, because consumer always can consume the item if item is available. So this is wrong. And option D, shared memory suffers from cache coherency issues which arise because shared data migrate among the several caches. So this is not at all related to this buffer problem because producer consumer buffer is not related to the cache. So option B is the right option here. Let us move on to the next question. Question number 45. Which one of the following is relevant to non-preemptive kernels? So here there are two things here, preemptive and non-preemptive scheduling. So preemptive means if a new job is arrived, there is a chance for present job to stop. And non-preemptive means once if job is taken for execution, at any cost we don't stop that process, okay, unless and until the process is finished. Okay, so these are the two things, preemptive and non-preemptive. So we are talking about the which one of the following is relevant to non-preemptive kernels. So non-preemptive means we don't allow to stop the process in the middle. Okay, if you see the options here, kernel allows a process to be preempted while it is running in a kernel mode. It will not happen because under preemptive kernels it happens. And option B, kernel data structure maintains list of all open files in the system. This is not related to the preemptive or non-preemptive, it is an independent statement. And a kernel does not allow a process running in a kernel mode to be preempted. A kernel mode process will run until it exits the kernel mode. Blocks yields control of the CPU. So that is what the right answer. Option C is correct. It will not allow the process to stop any of the activity while it is going unless and until it is finished it. Okay. And option D, prone to possible race conditions include structure for maintaining memory allocation, for maintaining process lists, and for interrupting handling. This is also independent statement which is not related to any of the preemptive and non-preemptive things. So the right answer for this question number 45 is option C. Now let's move on to the next question. I hope you are following, and yes. Next, question number 61. Which of the following is used to perform a transfer between two memory mapped devices without intervention of the CPU or the use of main memory? Option A, direct virtual memory access, and option B, cycle stealing, and option C, direct memory access, option D, programmed I/O. So without the intervention of CPU, if any device is doing the transfer means that is a DMA only. DMA is nothing but direct memory access. So this is a separate hardware. The DMA controller is responsible for initiating a bus request to the CPU. So as and when the bus is granted, the entire data that is to be transferred from memory to disk or disk to memory can be done by the CPU, the DMA controller without the intervention of CPU. CPU can continue to do on its own work other than utilizing the bus cycles. That's it. So that means this is the direct memory access option. C is the right option. Let's move on to the next question. Question number 62. Consider the division of the two numbers. So this is the dividend 0, 1, 0, 0, 0, 0, 0 and the divisor 0, 1, 1, 0. Then the quotient and the remainder are respectively. So we have to do the division. So both are positive numbers here. So there is no signed representation here. So x is equal to 0, 1, 0, 0, 0, 0, 0. This is the dividend. And what is the divisor? Divisor D is equal to 0, 1, 1, 0. Very simple. Actually, the value of this in decimal. So it's 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. That means 32. The value of x is equal to 32. That is a dividend. And the value of D, that is a divisor, is a 0, 1, 1, 0. That means 6. So when you divide 32 with 6, what happens? Both are positive numbers. Okay. When you divide 32 with 6, so 6 5s are 30, and what is the remainder? 2 is the remainder. Okay. So the quotient value Q is equal to 5. How I can represent 5? 5 is nothing but in 4 bits because all options are given in 4 bits. 0, 1, 0, 1. This is the quotient. And 2 is the remainder. It is shown in 3 bits. The value of 2 in 3 bits is 0, 1, 0. 0, 1, 0, 1 is the value of quotient, that is a 5, and the remainder is 2, that is a 0, 1, 0. So that is option A is the right option for this. Okay, that is a quotient and the remainder. I hope everybody understood this. Option A is the right option. Now let's move on to the next question. These are all the questions from computer organization and architecture. I hope every one of you have answered it correct. You can also ask your questions if you have any here in the chat box. And question number 63. Which one of the following threads is used to facilitate the designer of a program or system which might leave a hole in the software that only he or she is applicable and capable of using it? Option A, spyware. Option B, trapdoor. Option C, Trojan horse. And option D, logic bomb. Actually, this is a trapdoor, option B. I will tell you the reason. So basically, whenever you take any of the software designer, if they wanted to create a hole in the software where they only can control it and access it, so that the security threat is there for that particular hole, so that they can do that execution as and when they required. And also Trojan horse is actually, it is like an agent to the attacker, and it will steal the information, important information, and pass it to the attacker. So Trojan horse is not correct, and logic bomb also not correct, spyware is not correct. Option B is the right option. It's a trapdoor. Now let's move on to the next question. Question number 65. Which one of the following is a drawback of programmed and interrupt driven I/O? So this is a question related to I/O interfacing. So there are three activities for I/O data transfer. One is the programmed I/O, other is the interrupt initiated I/O, the last one is a direct memory access. So DMA. DMA is more advantageous when compared to programmed I/O and interrupt initiated I/O. Okay. In a programmed I/O, so continuously we have to monitor the devices in a regular intervals of time. As and when the device is having data to transfer, it will transfer by means of polling or daisy chaining, etc. But in the case of interrupt initiated I/O, so whenever there is program in execution, whatever the device that is require services, okay, that will interrupt the CPU. Then CPU stops the instructions execution by finishing the present instruction, and it will execute the interrupt service routine and come back to the place where it had stopped earlier and continue it. But whereas in DMA, CPU just initiate the DMA transfer, and the DMA controller will continuously transfer the data till it is finished, and then control of the bus will be given back to the CPU. So it's a fast transfer taken place in DMA when compared to programmed I/O and interrupt initiated I/O. So as per the options, they are asked about disadvantages of programmed I/O and interrupt initiated I/O. So option A, the processor is tied up in managing an I/O transfer. A number of instructions must be executed for each of the I/O transfer, because if it is interrupt initiated, interrupt service program must be executed. If it is a programmed I/O, continuously each device must be just monitored to check if there is any data to transfer. Okay, and all other options given, basically they are not related to the disadvantages. Individually I/O activities and programmed I/O activities are explained. That's it. So that's why option A is the right option. That's all for the computer organization and architecture. And let's see. One more question. Question number 66. Yes, one more question is there. Sorry. Question number 66. Which one of the following methods requires saving the value of the CPU registers from the thread being switched out and restoring the new thread being scheduled? Options are context switching between the kernel level threads, and option B scheduling switching, and option C kernel dispatcher, option D multi-level queue scheduling. Actually, multi-level queue scheduling is not at all related to these threads. Multi-level queue scheduling is a CPU scheduling activity, and kernel dispatcher also not related to this. Scheduling switching also not related to this. The correct answer is option A. The reason I will tell you. Which one of the following methods requires saving the value of CPU registers? So generally, when you are moving from one kernel level threads to other kernel level thread, switching between the threads, what is required is the CPU register. Each thread has to maintain a personal program computer value, some stack space, and also some CPU registers must be saved while you are switching from one thread to another thread. So that is called thread control block. So managing information in the thread control block, just like how we manage information in the process control block for the process. Okay, so kernel context switching is nothing but moving from one thread to another thread. So between kernel level threads requires the saving of CPU registers in the respective place, and then moving not only CPU registers, we also maintain some the program counter and some stack space also. Okay, and next question. Yeah, it is a pipeline question. This is a common reasoning question. Actually, these are the options given. Two statements are given, statement 1 and statement 2. Pipeline processing cycle overlaps computer instruction cycle in execution for the performance improvement. The statement 1 says about, if you wanted to improve the performance in the execution of instructions, we have to execute the instructions in a pipeline fashion. So what is a pipeline fashion? Overlapping of instructions. Overlapping of instruction. Instead of waiting completely till the instruction is finished. Okay, while one instruction is going to some later stages, next instructions can come to the first stage and then parallelly we can execute. Not completely parallel execution, maybe some overlapping. For example, while instruction 1 is fetching, you can't fetch 2, but while instruction 1 is in decoding phase, we can fetch the second instruction. So when you compare like that, pipeline processing cycle overlaps compute instruction cycle in execution for the performance improvement. So this is what we want, but how you can implement? So that is given clearly in the statement 2. Pipelining is a technique of decomposing a sequential process into sub operations like fetching instruction, decoding instruction, executing instruction, writing the operand, like that. So why we are dividing? For example, first instruction goes to second stage, second instruction can come to first stage, like that. But the same stage cannot be done by multiple instructions at a time. Okay, so individually statement 1 and 2 are correct, and 2 is actually, you see options, both statement 1 and statement 2 are individually true, and statement 2 is a correct explanation of statement 1. So we can implement this pipelining overlapping by dividing the instruction into different stages. That is what the statement 2 is. So statement 2 is the correct reason for statement 1. Option A is correct. That's all about computer organization and architecture. Thank you so much. Now some more questions. Rakesh sir, your favorite Rakesh sir is coming with which subject, sir?
The control system, digital and microprocessor.
Thank you. Thank you all. All the best.
Thank you, sir. So guys, now let's take on some questions for digital control system, digital electronics, microprocessors, all those things. Several questions discussed by Murli sir right now. Sir, what subject you just completed?
Computer organization.
Computer organization, correct, sir. Okay. Sir, how do you feel the level, computer organization for it?
It is average, sir.
Average, na? Because ECE this time is looking very simple. At least for the common subjects, it is simple.
exactly.
CO is out of their domain, out of their core area. So maybe they are, उनके लिए easy है तो better है. चलो. Okay guys, so control system. Alright. A second order system has the closed loop transfer function given by 25 upon s square plus 8s plus 25, settling time for 5% tolerance bend. Okay. Acha, first of all, if I talk about the zeta, na dekho, 2 zeta into omega n. Omega n kitna ho jayega, dear? From here I can say omega n will be 5 because omega n square is 25. So 2 zeta omega n is 8 and zeta is 8 by 10, or I can say 4 by 5, which is less than 1. I want to just confirm that whether it is underdamped or not. Otherwise, for critically damped we have a different formula. For overdamped we have to solve by the Laplace technique. ये बहुत लोग को पता ही नहीं होता. So because of the underdamped nature, and that too for the 5% tolerance, right? For the 5% tolerance, it is given by 3 by zeta omega n. So it should be 3 upon 4 by 5 into omega n 5. So the correct answer should be 3 by 4 seconds. Okay, it is the B. Correct answer is 3 by 4 seconds. That is option number B. That's it. Okay, chalo, very simple question. अगला question की तरफ move on करेंगे. Question number 32. Okay, the output of a standard second order system for unit step input is given to you. Gate PYQ copy question. Okay, what they have done this time we don't know. So output is given as 1 minus 1 upon root 3 by 2. I'm simplifying. Okay, e raised to the power minus alpha t cos of omega dt plus phi. You can use any of the parameters. Now I can say that from this term corresponds to, in the standard output step response, this term corresponds to root over 1 minus zeta square, right? So from here zeta, if you calculate, it will come up to be 1 by 2, right? And then यहाँ से मैं बोल सकता हूँ that alpha is equal to 1. Okay, that means alpha, which is also equal to zeta omega n, so that is 1. So zeta is half, the omega n will be 2. Okay, so what is the standard transfer function then? Okay, 2 square upon s square plus 2s plus 4, right? You have the omega n square upon s square plus 2 zeta omega n s plus omega n square, which will match with the option number D. Which will match with the option number D. So fundamentally very simple question. Moving ahead to the next question, that is number 33. Okay, number 33, ye raha. Okay, Consider a causal second order system. Again, a gate P by Q. Copied question. Gate 2019, I think. Gate 2019, 2 marks question it was. With the transfer function. Now, what is the type of transfer function given? You are given GS equal to 1 upon S square plus 2S plus 1. Or that is equal to S plus 1 whole square. And when you write down the poles of the system, the poles of the system are -1 and -1. That is real and repeated. And hence I can say that the system would be critically damped because the roots are real and repeated. And because the system is critically damped, step response will be given by, for critically damped, the step response is given by CT is equal to 1 minus e raised to the power minus omega nt into 1 plus omega nt. Okay, and what is going to be the value of omega n? The roots actually for critically damped are minus omega n minus omega n. So omega n ka value 1 ho jayega, and that is why you have the response as 1 minus e power minus t into 1 plus t. Now, because it is critically damped and unit step input, unity, is applied, I can say that the steady state value means limit t tending to infinity CT should be equal to 1. You can even apply the limit, or directly you can say, critically damped, that means it is going to reach the desired value of 1. The applied input is 1. Okay, so now what you need? You need CT is equal to reaching how much? Reaching 94%. Okay, that is 0.94 of the final value. Okay, now the problem here is the equation will not be solvable. 1 minus e raised to the power minus t, okay, into 1 plus t should be 0.94. You have no left with no option. You have to go with verifying the options, and it is going to be option number C, right? T is equal to 4.5. That is only possible by verifying the options. Clear hai? Okay, so the correct answer is C. Moving ahead to the next question in control system. This is done. Moving ahead to the next question. See, a fundamental definition here. Non-minimum phase transfer function is defined as the transfer function. So see, what is minimum phase? Where all poles and zeros are in the LHP. All poles and zeros are in the LHP. So if some of the poles and zeros are in the other side, that is RHP, system is non-minimum phase. But if poles are in RHP, then the system goes towards instability. That is why we just put down the zeros. Okay, we just talk commonly in terms of zeros. So which has zeros in the right half of S plane. Okay, it is the one which has the zeros in the right half of the S plane. Moving ahead to the next question. This was a very fundamental question. Okay, so what is this question, guys? A system has poles at 0.01, 1 and 80 and zeros at these frequency. So kya hai? Let us write down. You have the zeros. You have the zeros at 5, 100, 200, right? You have the poles at 0.01, 1 and 80, right? And what is the approximate phase? Now, before the corner frequency, we know that the phase contribution will be 0, and beyond that it is approximate phase. So beyond that, first approximation ki baat chalegi yahan pe. Beyond that it is plus 90 for a zero term, minus 90 for a pole term. So given frequency is 20 hertz, right? And that is greater than 0.01. That is greater than 0.01, that is greater than 1, and that is greater than 5, right? This is a pole, and this is a zero. So the phase after these frequencies, due to the pole minus 90, due to the next pole minus 90, then due to the zero it is plus 90. Net answer will become the minus 90 degree. The correct answer is going to be C. The correct answer is going to be C. The correct answer is going to be C. Right, moving ahead to the next question. Right? Okay, guys. Okay, chalo. The magnitude of gate P by Q, guys. The magnitude of frequency response of an underdamped second order system is 5 at 0 radian per second. Now, at 0 radian per second, if you take the standard transfer function omega n square, okay, divided by s square plus 2 zeta omega ns plus omega n square. If you put s equal to j0, you should get omega n square by omega n square, which is 1. but here it is going to be 5. So that simply means that the transfer function, okay, should be multiplied by 5, and then it peaks to 10 by root 3, right? So if it is 10 by root 3, 10 by root 3 को मैं multiply करूँ, मतलब 5 से separate करूँगा, so it should be 5 into 2 by root 3, and that is known as 5 into MR. So the MR formula, actually, this is a question on resonant peak. The MR formula is actually for the standard transfer function, right? So I can now say that my resonant peak is 2 by root 3, and that is given by the formula 1 upon sine 2 phi, right? And from here we can calculate what is the sine 2 phi. Right, this is applicable for phi greater than 45 degree. Okay, so sine 2 phi is equal to how much? Root 3 by 2, and that means 2 phi is equal to 60 degree or 120 degree. Okay, so what is the value of phi? 30 degree or 60 degree. Okay, so this is the correct answer. 60 nahi hatayenge. So what is going to be zeta? Zeta is cosine of phi, and cos 60 degree is half. So from here, at least I have got the value of zeta, that is equal to half. That is equal to half. Now, coming to the next part, that is the omega, and that we will get. Now, this peaks at what frequency? This peaks at what frequency? At 5 root 2. So, what is this 5 root 2? This is the resonant frequency. So, that is 5 root 2. So, omega r, omega n root over of 1 minus zeta square is 5 root 2. So, omega n under root of 1 minus 1 by 4, that is 5 root 2. So omega n kitna aa jayega? We just have to check that. Okay, so that was cos 60 degree, that is half. Phi should be greater than 45, then only zeta less than 1 by root 2. Perfect hai. So this should be looking like, kuch error ho raha hai kya? Omega n is not turning out to what I want. Okay, oh, sorry. Yeah, just a moment. Yeah, sorry, omega r hai na, that is given by omega n under root of 1 minus 2 zeta square, that is 5 root 2 na. So omega n into under root of 1 minus 2 by 4 equal to 5 root 2. Okay, just by chance I wrote the omega d formula. Okay, but you are all able to relate to it. Okay, so omega n 1 minus 1 by 2 is half. So under root of half is left is 5 root 2. Now it is perfect. So omega n kitna aa gaya? 5 root 2 into root 2, that will become 10. Right. So omega n is going to be 10. Omega n is going to be 10 and zeta is going to be half. Omega n is 10 and zeta is equal to the half. Clear, everybody? Zeta is equal to half. Okay, so we are going to match and you will get the answer. Omega n 10 hai, 10 square 100, but it has to be 500. Right, numerator should be 5 times omega n square. It is going to be correct answer, which is C. The correct answer for this is going to be the C. The correct answer for this is going to be C. Moving ahead to the next question then. Okay, moving ahead to the next question here. Okay, 37. By considering standard notations, the peak value, that is what is the formula I just told you, na? MR, it is 1 upon 2 zeta under root of 1 minus zeta square actually. Okay, that is the option number C. That is the standard formula. And I have the shortcut of writing it. Now, zeta is cos phi, so under root of 1 minus cos square theta is sine square is sine theta. So this becomes how much? This becomes the sine phi. This becomes the sine phi. So that is why I have given the direct formula 1 upon sine 2 phi. It is easy to solve like that. So iska answer C ho gaya. Ye to formula based question ho gaya. Okay, next 38. The phase margin of the system having the open loop transfer function. Okay, so phase margin is calculated at the gain crossover frequency. So dear, what is Gj omega Hj omega? What is Gj omega Hj omega? That is 2 root 3 by j omega into 1 plus j omega. So what is the magnitude? Mod Gj omega Hj omega. If I evaluate the magnitude, this is like 2 root 3 upon omega under root 1 plus omega square, and that should be 1 for the omega g. Okay, so solving from here, omega g ka square, okay, into 1 plus omega g ka square, taking the square, should be equal to 2 root 3 ka square, that will be 4 3s are 12, right? And now because it is going to become biquadratic equation, I will put omega g square equal to x to make it a quadratic equation. So equation finally aayega, this will be x square then plus x minus 12 equal to 0. Solving from here, x plus 4 and x minus 3. So x will be minus 4 and plus 3, right? But x is what? X is equal to omega ka square and frequency is real, so that omega square should be positive. So what is the omega g? Omega g is root 3. And now what is the angle Gj omega g? यहाँ डायरेक्टली ठीक है, चलो एंगल जी जे ओमेगा जी एच जे ओमेगा जी निकाल लेते हैं, एंड दैट इज इक्वल टू व्हाट इज द एंगल, न्यूमरेटर पॉजिटिव, डिनोमिनेटर प्योर इमेजिनरी माइनस 90 डिग्री, एंड देन यू हैव माइनस ऑफ tan inverse omega g, which is √3. Okay, so tan inverse √3 we all know is 60, so minus 150 is the phase, and phase margin is given by the formula 180 degree plus angle gj omega g hj omega g. Right, so 180 plus minus 150, 30 degree should be my last answer. It is the option number C. Okay, 30 degree is the last answer. Okay, chalo guys, next question here. I have few more questions. This is only control, then I have 8 to 9 questions of digital plus microprocessor. Okay, this is the last question of control, but then I have digital and microprocessor. The phase margin of the system with the open loop transfer function 1 minus s upon s plus 1 s plus 2. Guys, now when you calculate the gj omega hj omega, when you calculate the frequency response here, it has 1 minus j omega, but then it has 1 plus j omega in the denominator, which are conjugate terms, and that is why the magnitudes will be similar. So when I calculate mod gj omega hj omega, the magnitude of these two terms will get cancelled. You will have only 1 upon under root of 4 plus omega square. Isko equal to 1 karenge for omega g. Two questions on phase margin only. So that means denominator also should be 1. 4 plus omega g square equal to 1. So omega g square is minus 3. That means there cannot be any real solution. There is no real gain crossover frequency, and if there is no real gain crossover frequency, what I have taught you, that phase margin will be infinity. Okay, we have understood this through polar plots, we have understood through the formula, we have understood this through characteristic equation. Alag-alag tarike se isko samjha hai, but phase margin will be the infinity. The phase margin will be the infinity. Correct hai? Chalo, so D answer, that is the infinity. Next. Okay, 39. Yeah, now coming to the digital questions. Okay, it is a digital electronics, a priority encoder question. Okay, priority encoder. You know, digital mein actually most of the questions that are asked this time, most of the questions, they are on standard hardware results. I'll explain you like this. There is a 4-line to 2-line priority encoder, okay, with active high inputs and active high outputs, and the priority assigned to higher order data input. Okay, so let's say your data input is D0, D1, D2, D3, and your outputs are X and Y, right? These are your inputs, and I want to design a 4x2 priority encoder, and this is what the priority order is. Okay. Now, I'll tell you the fundamental. Okay, these are standard results. So, I have the inputs D0, D1, D2, D3. Okay, to design a priority encoder, we design some intermediate variables H0, H1, H2, H3, and based on them we produce the output, so that we know that if D0 is 1 and others are 0, the output should be 0, 0. If D0 is high, we make a condition such that H0 is high. If D1 is high, now D1 is having the higher priority as compared to D0. So if the D1 is high, D0 can be in any state. It should not matter. No? That is what priority means. If D1 is high, irrespective of the state of the D0, my output should be according to D1, and that is 0, 1. Okay. Now I arrange the signal so that whenever D1 is high, H1 should be high, but H0 should be 0. Similarly, guys, if D2 is high, okay, then I should not worry about the state of lower priority input, and here I should get H2 as high, and output should be according to D2, that is 1, 0. Similarly, D3, highest priority, if this is high, output should be according to D3, whatever may be the state of the lower priority inputs. But if D3 is high, we have to design a circuit so that H3 is high. Now, this particular column will look like a regular encoder column. Column 2 and 3, okay, will look like a regular binary encoder relation. Okay, so I'll tell you, you can just clearly see as well. What is the X? What is the X? X is high whenever H2 or H3 is high. Dekho 1, 1 kahan pe aaya hai? Whenever H2 or H3 is high. So this is known as H2 plus H3. And if I want to talk about Y, Y is high whenever H1 and H3 is high. So it is going to be H1 plus H3. But what is the intermediate signals? Okay, what are the intermediate signals? So now you can put down, okay, now you can put down what? Okay, now you are going to put down what? H1, H2, H3 मैं सारे आपको बता देता हूं. We start with H3. H3 is always D3, highest priority से start करेंगे. H2 it is given by D3 bar D2. H1 it is D3 bar D2 bar D1 only, and H0 depends on D3 bar D2 bar D1 bar and D0, so that whenever you add H2 and H3, इन दोनों को add किया तो you will get D3 plus D2. Okay, that is D3 plus D2, and similarly when you add 1 and 3 and apply the basic Boolean laws, you will get option number A as completely matching. Option number A will be completely matching for you. Correct? Option number A is the answer. Now, if you have studied these, setups, these hardwares thoroughly, so you may be able to remember also, but if not, we know the logic of solving priority encoder question. Okay, correct answer is going to be A. चलते हैं अगले question की तरफ. Next question. How many flip-flops are required to build a binary counter that counts from 0 to 4096? That is 0 to 4095. 4096 steps it has. Right, and 4096 is nothing but 2 power 12. Exactly 2 power 12. So we need 12 flip-flops. We need the 12 flip-flops to implement 2 power 12 steps, 2 power 12 counts. Okay, moving ahead to the next question then. 21. Again, guys, a direct hardware question. So this is what you regularly study in the theory. How to design multipliers, comparators, adders, encoders, priority encoders. So I'll just give you the direct answer for this. Okay, a 2-bit binary multiplier can be implemented using 2 half adders and 4 2-input AND gates. 2 half adders and 4 2-input AND gates. Correct answer is B. Moving ahead to the next question here. Okay, now guys, again see direct hardware question. For a binary half subtractor having 2 inputs A and B, the correct set of logical expression for difference is A XOR B. Okay, so that is D or B, and the borrow is A bar B, right? The borrow is generated when A is less than B. Okay, A0, B1, so that is why A bar B. The correct answer should be C. Okay, correct answer should be the C. We are talking about subtraction of A and B. Right. Chalo guys, so correct answer is the C. Okay, and then let us move ahead to the next question. Number 23, which again guys, direct question logic family. Okay, ECL has the least propagation delay. Yes, it is all about least propagation delay. ECL is the fastest one. Acha, CMOS has the highest power dissipation. No, CMOS is known for the lower and lower power dissipation. Okay, lowest power dissipation. So that is why A is the correct answer. A is the correct answer. Fastest logic family, ECL. Okay. 24. Each cell of a static RAM, guys, the 60 model, each cell of a static random access memory, SRAM pe question hai ye. Okay, and each cell has how many transistors? 6 transistors. This is known as the 60 model. Okay, which is implemented using the CMOS logic family. Factual questions. You have studied once, you know the answer. Okay, you know the answer. And for SRAM, we don't use these capacitors, na? The question is about SRAM, not the DRAM. Okay, next question की तरफ चलते हैं. Okay, coming to the microprocessor 8085 questions. Okay, the following sequence of instruction is executed by 8085 microprocessor. Okay, LXI SP, 27FF, call 1000H and pop H. Now guys, after the first instruction, question में क्या पूछा है? What is the contents of stack pointer and HL register pair on the completion of these instructions? So first is LXI SP, LXI load register pair immediate. Okay, so this is going to load the stack pointer with 27FF with the data. Load register pair immediate with the immediate data loaded on the SP. Then call 1006. Now call is the instruction to call subroutine which is located at the address 1006. But after the completion of subroutine, I know, okay, whenever the program will return from the subroutine, it will return to where? It will return to the next instruction. Where is the next instruction written? 1006. So what is done? अगर मैं इसकी बात करूं separately, call 1006. After this, the address of the next instruction, that is 1006 actually only here. Coincidentally 1006 hai, but whatever is the next address, this has to be stored on the stack. Okay, so हम क्या करेंगे? Call 1006 and here it is 1006. Okay, so top of stack will be fed with 1006, this one. Okay, इससे कोई लेना देना नहीं है. This one, which is the memory address of next instruction. See, coincidentally, this is also 1006, but इससे कोई लेना देना नहीं है. On the top of stack, we store the memory address of the next instruction. Okay, so top of stacks get 1006. But whenever we are storing on stack, it is like a push operation. It is like a push operation, right? So there are two things that will happen. Stack pointer will be decremented by 2. That is 27FF minus 2. That is 27FD. Correct? Okay, these are the two things that will happen. Now, when I go to 1006, I see a pop H, and pop retrieving from stack will increment the stack pointer by 2. So here you will get stack pointer, which was already 27FD added with 2. So it will again become 27FF. So stack pointer will be 27FF. That is clear. Okay, so it is option A or C. But what is HL? Now pop H. Pop is used to retrieve the contents of top of stack into the HL register pair. Right. So HL will get the contents of top two memory locations of stack, and that is what is there in top T of S? T of S 1006. Right. So HL should get 1006. So correct answer should be the C. 27FF and 1006. 27FF and the 1006. Correct answer is C. Moving ahead to the next question. Are you okay, guys? Moving ahead to the next question here. Okay, 25th ho gaya. 26. The total number of memory access involved when 8085 executes LDA instruction load accumulator direct. Load accumulator direct. It is used to load the contents of specified memory location into accumulator, right? And because a memory address is involved, it is going to be a 3-byte instruction. Machine cycles nahi bola, 3-byte instruction. Number 1, opcode fetch. Then to read the 16-bit address, okay, the data bus in 8085 is 8 bits only, na? So I need to go to the memory 2 times. MR, okay, and then after reading the memory address 2003, microprocessor knows that finally it has to go to the memory address 2003 and copy the data into the accumulator. That is what is load accumulator data direct. So one more time memory read is required, so 4 cycles will be there. One more time, and that is, even if there are the sequence, you must be able to say opcode fetch, memory read, memory read, memory read. Opcode fetch, memory read, memory read, memory read. The correct answer is the D. Everybody, the correct answer is going to be the D. Opcode fetch followed by 3 memory read cycles. Moving ahead to the next question here, that is number 27. The contents of the register B and accumulator A are given to you. Okay, so B has 3C and accumulator has 8-9. The contents of accumulator and status of carry flag and sign flag after executing the sub B instruction. The very simple question, sub B. Acha, sub B means subtract B. Subtract from what? Subtract the contents of register B from the contents of accumulator and store the result back into the accumulator. Now, ab aap dekhoge, it is like accumulator 8-9 minus B has 3C. MSB 8 bada hai. That means whenever you have a bigger content, na? Okay, I can just judge the answer just like that. 8-9 is greater than 3C, right? So will there be any borrow required? And if there is no borrow required, no borrow, na? So there will be carry flag reset because there is no borrow. Acha, bigger minus, bada minus, chota number, bigger minus smaller number, the answer is positive, right? Next line that I can write is answer equal to positive, and because answer is positive, the sign flag will be 0 because sign flag is the value of the MSB. And for positive number, MSB is 0. So sign flag be 0 hoga. So fundamentally, this is again one question which is, there is no option matching for this. Okay, there is no option matching for this, right? So, you know, just 1 or 2 questions we saw in the paper number 1 as well. Okay, here this is one example. No options will be matching. Carry flag and sign flag both have to be reset because in a subtraction process, if borrow is required, then the carry flag is set. Chalo, ye to ho gaya fundamentals. Even if you try to solve the subtraction, चलो, even if you try to solve the subtraction, यहां से भी देख सकते हैं 8-9 minus 3C, right? So borrow will be required, 9 is less than C, borrow will be required, this becomes 1-9 then, and this is going to become 7. Now 19 minus C, DEF 104 and then plus 9 13. So this is 13. 13 bole to hexa mein D. You can solve in binary also. I am dealing in the hexa directly. So this should be D. 7 minus 3 is 4. So answer is 4D. Nowhere we have the 4D. So I think there is some typo error with the data. There is no big problem. Question is straightforward, right? So according to me, none of the option is matching. And yahan pe dekh lo na. When I have completed the subtraction, where is the final borrow or final carry? Not required, na? Not required. So that is why it's straightforward. I told you carry 0 hoga, carry is raised when borrow is required. Chalo guys, so next question, none of them is matching in this question. No problem. Question number 28 from the microprocessor. Here it is. Okay, for the 8085 microprocessor, the following program is executed. MVI A, 05, MVI B, 05, PTR, it's a label given, add B. Now, add B. So, add B means what? Again, the contents of accumulator will be added with B and the result is stored back in the accumulator. So, accumulator will be how much? 05 plus 05, that is known as 0A. Hexadecimal mein chalenge. That is known as 0A. Now, I decrement B. So, B was 5. Now, it will become 4. Okay. J and Z. What is J and Z? Conditional jump instruction. J and Z. Jump on non-zero. Okay, to PTR. So, if the result is non-zero, yes, it is non-zero. So, I will jump back to the PTR. Okay, so I'll jump back means I can again add B. So what will be the next result? Ab sequence mein likhte jate hain. What is going to be the next result? B is now 4. You are adding B and B was decremented. So A plus 4 will become kitna? 14. That is E. Okay, so next is E. Okay, now again decrement B. So it will become 03. Is it non-zero? Yes, it is still non-zero. So again go back and add. Right, add this time 3. Right, E plus 3. The F 1011. So next is going to be what? Next is going to be 11. यहाँ लिख देते हैं. Right. ठीक है. Now again decrement. So this is 02. It is still non-zero. So again go and add. Right. So now next it is going to be 13. Every time B is added, reduced B. So 11 plus 2 to 13. Okay. Now again I will decrement. तो ये हो जाएगा 01. Right. Again I will go back and add 01. So 13 plus 01 is 14. Now I will decrement. Now I will going to get 0. Right. And when I get 0, I'll directly jump to this instruction. Jump on no 0. If the result is non-zero, then jump. But my result is 0. So I will not jump. If I don't jump, I'll go to the next instruction. ADI, add immediate. ADI, add immediate instruction. Add the given immediate data with the contents of accumulator. So accumulator, which was already 14, now will be added with 03. So 17 is my last answer because the program halts here. The correct answer is 17. The correct answer is known as A, that is 17. Right. Okay. Okay. Yes, dreams, tell me. Oh, maybe in the flow of question I did not see. Okay. Less aspirants for ESE every time ना. EC का तो यही कहानी है engineering services में dreams. Right, no problem. Aspirants ही बहुत less है. And I think that is why this time UPSC has given a relatively simpler paper also for ESE, at least electronics and telecommunication. So now I have Ishan sir. Sir, what subject?
Sir, I have a basic electrical.
Basic electrical. Sir, although electrical तो थोड़ा electronics वालों के लिए वो disturbing element होता है, but कैसा level है इस बार?
Sir, basics ही है, मतलब ऐसा कोई high-fi question नहीं पूछा गया है, so they have just on a basic formula-based question.
चलो, great. So sir, continue.
So, hello students. So I'm going to solve questions from a basic electrical part. So अगर बेसिक इलेक्ट्रिकल पार्ट देखा जाए तो यस ईएनटी वाले स्टूडेंट्स के लिए पार्ट थोड़ा सा डिफिकल्ट रहता है, लेकिन अगर आप क्वेश्चन का लेवल देखोगे, क्वेश्चन का लेवल आपका सिंपल साइड आया है. ऐसा नहीं है कि आपका क्वेश्चन थोड़ा काफी ज्यादा हार्ड आ गया है या फिर कुछ और. तो क्वेश्चन का लेवल सिंपल है. तो वी विल स्टार्ट विद द क्वेश्चन. सो अप्रोक्सीमेटली इफ आई एम नॉट रॉन्ग तो 9 to 10 क्वेश्चन आए हैं. अगर कोई और एक्स्ट्रा क्वेश्चन हो तो हमें बता देना. ओके ड्रीम्स, कोई नहीं बेटा, आप ध्यान से क्वेश्चन को देखो. अगर कोई कुछ बोल नहीं रहा है चिंता मत करो, जस्ट फोकस ऑन योरसेल्फ. सो क्वेश्चन सिंपल है ये वाला. अगर आप देखा जाए तो बेसिक इलेक्ट्रॉनिक्स में भी आप ये क्वेश्चन को पढ़ सकते हो. सो लेट्स सॉल्व दिस क्वेश्चन केयरफुली. सो द क्वेश्चन इज द सेल्फ इंडक्टेंस, वेट अ सेक. The self-inductance of 3 coils are LA, LB, LC. The coils are connected in series in such a way that fluxes of LA and LB are added. Flux of LA and LC are in a position and flux of LB and LC are in a position. And we have given a mutual inductance also. Then what is the total inductance of a circuit? Okay, simple question है. तो सबसे पहले मैं आपको बता दूं बेसिक फॉर्मूला जो इसके अंदर यूज होता है. If we have 2 inductor, let's suppose L1 and L2. So in case of addition, means when flux are not in a position, when flux support each other or in addition, then the formula is L1 plus L2 plus 2 times of mutual inductance M12. In case of addition, let me write down. In case of addition. In case of opposition, the formula is L1, L2 minus 2 times of M12 in case of opposition. Okay, so in this question we have given 3 inductance, okay, LA, LB, LC. So we can write down what is the total inductance according to question. Since all the inductance are in series, so we can write down LA plus LB plus LC. Now read carefully, LA and LC are in opposition. Okay, nice. First of all, LA and LB are in addition. So we have to write down plus 2 times of MAB. Then they are saying A and C are in opposition. So minus 2 times of MAC. And B and C are in opposition. So minus 2 times of MBC. So according to question, we can form this equation. And equation mushkil bhi nahi hai. If you remember this basic formula, then your answer is very much simple. So LA is 20 plus 30 plus 40 plus 2 times of 8 minus 2 times of MBC, which is 12, okay, given in question, minus 2 times, MAC is 10, okay, my fault, MAC is 10, MAC is 10, and what is MBC? MBC is 12, okay, to multiply by 12. So after solving this, we will get 62 Henry as an answer. Okay, so option B is the right answer. After solving this, we will get 62 Henry as the answer. है ना, सिंपल क्वेश्चन है. जस्ट ये जो बेसिक पॉइंट है ये आपको पता होना चाहिए. नाउ नेक्स्ट क्वेश्चन. So a 100 kV 50 hertz single phase transformer has a ratio of secondary to primary turns. The important point is this line. Secondary to primary turns as 0.1. It means N2 divided by N1 is equal to 0.1. The voltage at no load condition, the secondary voltage. So the secondary voltage given is 100 volt. Now the question is, what is the value of primary voltage? So they are asking कि primary voltage में हमारे पास क्या value होगी. तो simple है, आपको simple पता है. We in a transformer, in a single phase transformer or in a 3-phase also, we can use this transformation equation. काफी इंपॉर्टेंट इक्वेशन है, ठीक है. और इलेक्ट्रॉनिक्स में ज्यादातर जो ट्रांसफॉर्मर के क्वेश्चन आते हैं वो इसी इक्वेशन में से आते हैं. या तो वोल्टेज की इक्वेशन होगी या तो आपके पास करंट की इक्वेशन होगी, है ना. So from here, we need to find out the V1, I guess, right? So V1 is equal to N1 by N2. It means 1 upon 0.1 multiply by V2, which is 100. So it comes out to be 1000 volt. So option C is the right answer. है ना, सिंपल क्वेश्चन है, कोई डाउट इसमें किसी को, है ना. एंड बच्चों सेशन को ज्यादा से ज्यादा शेयर करो जिससे कि आपके जो फ्रेंड्स है उनको भी पता चले कि सॉल्यूशन या आंसर्स आपके ईएसई एग्जाम में कैसा आए. प्लस ईएसई के क्वेश्चन आपके स्टेट एग्जाम में भी काफी इंपॉर्टेंट होते हैं. तो यू हैव टू सॉल्व अ पेपर ऑफ ईएसई बिफोर गोइंग टू अटेम्प्ट एनी एई और जेई एग्जाम. नेक्स्ट, a 230 volt DC shunt machine. So this is a very good question, and if I say for the electronics student, it's go to the moderate side. Okay, it's not that much easier if you are from electronics background. So we are talking about a DC shunt machine. So let me draw a DC shunt machine first. So DC shunt machine means the field winding is in shunt with respect to the armature circuit. So we have an armature circuit where this is a back EMF, this is armature resistance, and this is the field winding. So since field winding are connected with a shunt of armature circuit, we have a DC shunt machine, and this is going to be a terminal voltage. Now few points you need to understand to solve this question. First of all, the direction of field current is always in this direction. Okay. Now they're talking about that if armature resistance is 0.5, field resistance is 115, what are the value of EMF induced when the machine acts as a generator as well as the motor? And the line current is 50 ampere. Line current is 50 ampere and 230 volt is the terminal voltage. So if I talk about the field current, see, फील्ड करंट का डायरेक्शन और वैल्यू चेंज नहीं होती चाहे आप उसको एज ए जनरेटर यूज करो या मोटर यूज करो. ठीक है, तो मैं फील्ड करंट निकाल सकता हूं डायरेक्टली. फर्स्ट ऑफ ऑल, फील्ड करंट इज इक्वल टू टर्मिनल वोल्टेज डिवाइड बाय आरएफ. इट मींस 230 वोल्ट डिवाइड बाय आरएफ 115. इट कम्स आउट टू बी 2 एम्पियर, है ना, तो फील्ड करंट मेरे पास सेम रहेगा। ना अंडरस्टैंड द क्वेश्चन, अगर मैं इसको एज ए जनरेटर लेके चल रहा हूं, ठीक है, तो यहां पर ध्यान से देखना बच्चों, इफ आई एम टेकिंग इट एज ए जनरेटर, तो जनरेटर में दिस इज द डायरेक्शन ऑफ लाइन करंट, दिस इज द डायरेक्शन ऑफ लाइन करंट, दिस इज द डायरेक्शन ऑफ आर्मेचर करंट इन केस ऑफ जनरेटर। सो अगर ये डायरेक्शन है तो मैं यहां पर लिख सकता हूं व्हाट इज द आर्मेचर करंट, आर्मेचर करंट इज इक्वल टू लाइन करंट प्लस फील्ड करंट, है ना, बस केसीएल लगाओ, बस केसीएल। सो लाइन करंट 50 है मेरे पास, फील्ड करंट 2 है, सो इट कम्स आउट टू बी 52 एम्पियर, इट कम्स आउट टू बी 52 एम्पियर। नाउ व्हाट इज द ईएमएफ ई, तो आप केवीएल लगा सकते हो, यहां पर केवीएल लगाओ, सो ईएमएफ ई विल बी इक्वल टू वीटी प्लस आईएआरए, सो टर्मिनल वोल्टेज इज 230 वोल्ट, armature current is 52 and RA is 0.5, so bacha it comes out to be 256 volt. And if you see the options, only option A has given a 256 volt answer, है ना, when it is used as a generator, it is important. So here they are talking about a generator first, so the answer is 256 volt. Okay, now what will happen in case of motor? The answer comes out to be 206, but let me just explain you without solving a question. In case of motor, bachcho, what will happen? The direction of line current will change. This will be the direction of line current, this will be the direction of armature current. In case of motor, again you will have to apply the KCL. Armature current comes out to be 50 minus 2 equal to 48, and then in this equation there will be a minus sign here, nothing else. Okay, but अगर मैं एग्जाम की बात करूं तो एग्जाम में जस्ट आपको एक ही ऑप्शन दिया हुआ था जिसमें 256 वोल्ट है, एंड हेंस दैट विल बी द आंसर। वेरी लाइटली शोर्ट सॉल्यूशन। ओके, आई विल चेंज द पेन। ओके फाइन, आई विल चेंज द पेन बच्चे, नो प्रॉब्लम। ओके नेक्स्ट question, a 4-pole 3-phase induction motor is this is a trick question, this is a trick question. Okay, why? Let's see. A 4-pole 3-phase induction motor is supplied from 50 hertz AC supply, 50 hertz AC supply, and the full load speed of a motor is 1455 rpm. So according to question, the NR is given 455 rpm. We can find out the synchronous speed. So if you know about an induction motor, even a synchronous motor, then what is the synchronous speed? The simple formula is 120 F by P, simple formula. So 120 multiplied by frequency, which is 50, divided by 4, it comes out to be 1500 rpm. This is the synchronous speed, है ना? Now in the question they are asking what is the slip. तो स्लिप का फॉर्मूला क्या होता है? स्लिप का फॉर्मूला क्या होता है? स्लिप इज इक्वल टू ns माइनस nr डिवाइड बाय ns. नाउ व्हाट इज ns? इट इज 1500. व्हाट इज nr? इट इज 1455. व्हाट इज ns? अगेन इट इज 1500. आफ्टर सॉल्विंग दिस वी विल गेट 0.03. So this is the slip according to the data we have given here. Now what is the trick here? The trick is they are asking the frequency of the rotor at stand still. ये इंपॉर्टेंट है, स्टैंड स्टिल पे पूछी है। स्टैंड स्टिल पे याद रखना जो रोटर स्पीड होती है दैट इज इक्वल टू द स्टेटर फ्रीक्वेंसी, द रोटर फ्रीक्वेंसी इज इक्वल टू द स्टेटर फ्रीक्वेंसी व्हेन इन केस ऑफ स्टैंड स्टिल, जब मोटर आपकी नहीं घूम रही, व्हेन देयर इज नो रोटेशन। अदरवाइज क्या होता है? Otherwise, when rotor is moving, then rotor frequency is equal to f times of stator frequency. जब आपका इंडक्शन मोटर रनिंग पे, ठीक है, बट दे आर टॉकिंग अबाउट स्टैंड स्टिल, सो द आंसर इज 50 हर्ट्ज. तो ऑप्शन बी इज द राइट आंसर बिकॉज सप्लाई आपकी 50 हर्ट्ज है, ठीक है. और आप देखोगे 1.5 नहीं दिया ऑल दो, तो ऑप्शन इज बी हियर. But remember, this is a very important point, and this is a trick they have used in this question. That during running we have s times of fs, standstill पे fs के equal है. Next, now ये simple question है, ये बहुत simple question है. Means अगर आपने पढ़ा होगा तो आप बता सकते हो, अगर आपने नहीं करा होगा नहीं बता सकते हो. It's a question based on a power plant. तो सिंपल ये है कि the pressurized water reactor is similar to boiling water reactor except the coolant water is pumped through the reactor under high pressure. तो जब प्रेशराइज वाटर रिएक्टर है मींस हमारे पास पावर प्लांट्स में काफी टाइप के रिएक्टर्स होती है, उसमें से दो रिएक्टर है, प्रेशराइज वाटर एंड द बॉइलिंग वाटर रिएक्टर, PWR, BWR, मे बी आप लोगों ने सुना होगा, ठीक है। तो इन केस ऑफ PWR कूलेंट का प्रेशर आपका हाई होता है एज कंपेयर टू BWR, और इसके पीछे रीजन भी है। रीजन ये है कि बॉइलिंग वाटर में आप कूलेंट को कन्वर्ट कर देते हो स्टीम में, बट in case of pressurized water we don't want steam, we want the water comes at high temperature and high pressure so that the particular rotor can rotate, okay, but still अगर आपने पढ़ा होगा तभी इसका आंसर दे पाओगे, otherwise no, it's just a memory based question. Correct, Pinky has given a right answer. Now this question, okay, the question is a discharge battery is charged at 6 ampere for 3 hours after which it is discharged through a resistor R ohm. If the discharge period is 7 hours and the terminal voltage remain fixed at 12 volt, what is the value of R approximately, assuming that ampere hour efficiency of the battery is 85%? Okay, so data given है बहुत सारा. So simply मैं बात करूं तो मेरे पास एक बैटरी है, ठीक है, मैं इसको B से शो कर रहा हूं, ठीक है। इस बैटरी के अक्रॉस कुछ ना कुछ टर्मिनल वोल्टेज है, ठीक है, एंड देन वी हैव अ रेसिस्टर जिसके अक्रॉस बैटरी डिस्चार्ज हो रही है, ठीक है। नाउ अकॉर्डिंग टू क्वेश्चन टर्मिनल वोल्टेज दिया है मुझे 12 वोल्ट। अगर मैं डिस्चार्जिंग करंट फाइंड कर लूं, ID इज द डिस्चार्जिंग करंट, ID इज द डिस्चार्जिंग करंट हियर। अगर मैं कैसे भी करके डिस्चार्जिंग करंट फाइंड कर लूं देन R कितना हो जाएगा, टर्मिनल वोल्टेज डिवाइड बाय डिस्चार्जिंग करंट। सो बेसिकली यहां पर सबसे पहले हमें डिस्चार्जिंग करंट फाइंड करना है। अब वो कैसे फाइंड करेंगे, अब क्वेश्चन के अकॉर्डिंग वी हैव गिवन एफिशिएंसी इज 85%, बट याद रखना ये कौन सी एफिशिएंसी है, एम्पियर आवर एफिशिएंसी, व्हिच मींस करंट मल्टीप्लाई बाय टाइम, सिंपल सी बात है। सो मैं एफिशिएंसी की बात करूं तो आउटपुट एनर्जी डिवाइड बाय इनपुट एनर्जी इज इक्वल टू 0.85। आप ये भी बोल सकते हो इट इज अ स्टोर्ड एनर्जी इनसाइड अ बैटरी। सो जब ये बैटरी चार्ज हुई है 3 आवर्स 6 एम्पियर के लिए, तो कितनी एनर्जी इसने स्टोर करी, इट हैज स्टोर द एनर्जी ऑफ 6 मल्टीप्लाई बाय 3 मल्टीप्लाई बाय 0.85। सो आउटपुट एनर्जी कम्स आउट टू बी हाउ मच, लेट मी सॉल्व यूजिंग कैलकुलेटर, वेट अ सेक, $15.3, it comes out to be 15.3 ampere hour. Now this is the amount of energy that has been discharged across a resistor in 7 hours. So what is the discharging current? Discharging current multiplied by 7 hours is 15.3. Okay, remember this thing. Why? Because output energy ampere hour में निकाली हमने, है ना, तो discharging current में find कर सकता हूँ because in a question it is given that it has been discharged in 7 hours. So from here discharging current comes out to be 2.18 ampere. This is the discharging current. Then what is the resistor? 12 volt divided by 2.18, तो I guess 5 के आसपास आ रहा है, yeah, so it comes out to be 5.5 ohms, और अगर आप देखोगे तो 5.49 ohm. So obviously option B is the right answer. So obviously option B is the right answer. हाँ सही है, 5.49 ohm. ओके, सो अंडरस्टैंड क्वेश्चन की लैंग्वेज समझो, लैंग्वेज समझ जाओगे तो आंसर भी आप इजीली निकाल लोगे। इसमें आपने इलेक्ट्रिकल कॉन्सेप्ट कुछ यूज नहीं करा है, बेसिक आप इलेक्ट्रॉनिक्स या नेटवर्क थ्योरी का भी कॉन्सेप्ट इसमें बोल सकते हो, राइट? कोई डाउट इसके अंदर? गुड। नेक्स्ट, a coil consists of 1000 turns. So we have given 1000 turns of copper wire having a cross sectional area of 0.8 mm square. The mean length per turn is 80 centimeter and the resistivity of copper is 0.02 micro ohm meter. What are the value of resistance and the power absorbed for the 100 volt? Simple है। कैसे? सबसे पहले टोटल लेंथ निकाल लो। टोटल लेंथ क्या होगी? They have given mean length per turn is 80 centimeter. So total turn is number of turns multiplied by mean length, or I can say length per turn. So it will be 1000 multiply by 80 into 10 raised to power minus 2 meters. Okay. Now, what is the formula of resistance? Resistance is rho L by A. Now, rho is given how much? They have given the resistivity of a copper is 0.02. Okay, 0.02 into 10 raised to power minus 6. Length is 1000 into 80 into 10 raised to power minus 2 divide by area. Area is given 0.8 mm square. So 0.8 into 10 raised to power minus 6 meter square. So इसको अगर हम solve करें तो कितना आएगा? It comes out to be 20 ohms. So it comes out to be 20 ohms. Simple है. Simple formula लगाया यहाँ पर हमने resistance का rho L by A. Simple formula है. Now they are asking what is the power absorbed by the coil when connect across 100 volt. Okay. So अगर मैं 100 volt की मैं बात करूँ, so power is equal to V square divide by R. So it will be 100 whole square divide by 20. It comes out to be 500 watt. एक बार चेक कर लो. हाँ, correct. Option C is the right answer. Option C is the right answer. Okay. याद रखना, resistor power absorb करती है, absorb करने के बाद dissipate करती है. Whereas inductor and capacitor store that absorb energy. Okay. Simple concept है, कोई doubt नहीं होना चाहिए इसके अंदर. But फिर भी कोई doubt है, you can ask it freely. Next. So a coil consists of 750 turns and a current of 10 ampere in the coil give rise to a magnetic flux of 1200 microweber. What are the inductance of the coil and the average EMF induced in a coil when the current is reversed in 0.1 second respectively? Simple formula based question. अगर मैं inductance की बात करूं, inductance का formula क्या होता है? N times of phi divide by I. We also call it a flux linkage. Okay, so number of turns is given how much? 750. Flux they have given 1200 microweber and the current is given I guess 10. Okay, so if I solve this equation, let me see क्या आंसर आएगा. So it comes out to be 0.09 Henry. 0.09 Henry. Okay, simple है ना? If you remember this formula, then only you can solve the question. And this formula, it's not only from electrical. If you see the in your particular network theory, in network theory also in a basics, we remember this formula. We have to work with this formula. है ना? Then they are asking what is the EMF induced. EMF is equal to minus d phi by dt. Minus d phi by dt. But they are talking about magnitude. So if they are talking about magnitude, there is no need to use the minus sign. Okay, there is no need to use the minus sign. So change in flux is 1200. Change in flux is 1200. And what is the change in time? That is 0.01 multiply by 10 raised to power minus 6 because of microweber. Because of microweber. Okay, sorry, I forget to put n d phi by dt. Sorry, I forget to put n d phi by dt. So it will be n is how much? 750. So it will be 750 multiplied by 1200 and it comes out to be 90 volts. It comes out to be 90 volts. Oh, let me check. Okay, they are talking about if the current is reversed. Okay, my fault, bachcho, my fault. Let me tell you again. This is important. What they are talking about? They're talking about when this current is reversed. So when, if you know that flux is directly proportional to current. So if current is reversed, so I can say what is the change in flux? The change in flux is equal to final flux minus initial flux. If the current is reversed, understand this point. If the current is reversed, the flux will also reverse. So can I say the final flux is actually equal to initial flux minus initial flux? Why? Because अगर current reverse हुआ है तो आपका flux भी तो reverse हुआ है. So from here I can say what is the change in flux? It is minus 2 times of phi I. This is the change in flux. Finally I can write down what is EMF. It is minus and d phi by dt. Now you can put values here. So if I put values here, it will be minus 750 multiply minus 2 multiply by phi I. It is 1200. Okay, let me erase this thing. because this we have already solved. So multiply by 1200 multiply by 10 is to power minus 6 divide by change in time is 0.01. So from here I can get the answer 180 volt. Option A is the right answer. Correct, Pinky. Pinky has given a right formula. So it will be 180 volt. Remember this concept. This is important here. Okay? Because when a current is reversed, the flux will also reversed. Right? Next, which one of the following is related to the properties of a good insulating material? Simple hai. Option A is the right answer. If you have a good insulating a material, then what are the good properties? Very simple hai. Kaise? It should have a high dielectric strength. Obviously, agar dielectric strength kam hoga, then it will going to break down. And if it's going to break down, it's not a good insulating material. Very low dissipation factor. Again, the dissipation factor agar high hoga, to then losses इसमें काफी ज़्यादा होंगे, and again it will not be a good insulating material. And operating temperature limit should be high. So option A is the right answer. Okay. Now again, this is a simple question, but memory based question hai. If you know about harmonics, then you can solve this question easily. Otherwise, अगर आपको harmonics के बारे में नहीं पता होगा, तो आप ये question solve नहीं कर पाओगे. तो simple सी बात है, they are talking about square wave. Now square wave की अगर बात करूँ, simple एक square wave की अगर बात करूँ मैं, a square wave can be represented like this. This is x, this is minus x. Then for this square wave, अगर मैं इसका Fourier series find करूँ, अगर मैं इसका Fourier series find करूं, that will be 4x divided by n pi sin n omega t, where it is from n equal to 1, 3, 5 infinity. So this is the Fourier series of a square wave. Now in this Fourier series you can note that जो harmonics है वो आपके odd harmonics है, 3, 5 and 7. First क्या होता है? Fundamental component. So according to a square wave, we have made up of a fundamental frequency plus an infinite number of odd harmonics. So P will match with option 2. Now अगर आप triangular wave को देखोगे तो it is very much close to the sinusoidal waveform, है ना? तो triangular waveform में जो harmonics होते हैं that are less as compared to square wave. तो Q has option 1 and the last option is third. So the answer should be 213. 213. Option A is the right answer. 213. Option A is the right answer. Okay. So I guess the questions of so yes bacho. So I guess 1 or 2 questions are left for the in your basic electrical, and but wo jo questions hai, again that's a memory based question. Okay, so that we will give you in a PDF. But tell me guys, how's your paper? Okay, I can see there are few people online. Can you tell me आप लोगों का पेपर कैसा गया या किस पर्टिकुलर सब्जेक्ट में आपको डिफिकल्टी लगी? Tell me. Can you tell me in which subject you will feel the difficulty? No one? Okay. So अगर मैं एनालिसिस करूं पेपर की, जैसे कि अभी भी राकेश सर ने कहा था कि जो ENT का पेपर है that is much closer to the easier side, and ये मुझे फील भी करा. ठीक है, we have solved, मतलब अगर पर्सनल लेवल बात करूं, so we have solved the question from a network theory, है ना, और बेसिक इलेक्ट्रिकल मैंने आपको करा ही दिया. तो नेटवर्क थ्योरी और बेसिक इलेक्ट्रिकल काफी ज्यादा क्लोज लगे, तो इससे आई डोंट फील कि आप लोगों के लिए एक डिसएडवांटेज लेवल है कि इलेक्ट्रिकल के क्वेश्चन आ गए, है ना. हाँ, कुछ क्वेश्चंस है जैसे मैंने बात करी थी, इससे पहले बात करूं, 1-2 क्वेश्चन थे जैसे कि इंडक्शन मोटर, हाँ, हार्मोनिक्स क्वेश्चन, दिस वन, ये 2-3 क्वेश्चन है जो आप लोगों के इलेक्ट्रिकल से आगे, बट ये सबके लिए, नॉट ओनली फॉर यू, फॉर ऑल द ECE स्टूडेंट. सो डोंट वरी, अगर आपको बेसिकली आपको इनके आइडिया नहीं है तो सबका ही अगर गलत हो गया सबका ही सही होगा, यही बात है. ठीक है. और अगर बात करें दूसरे सब्जेक्ट्स की, लाइक एनालॉग की बात करूं, तो एनालॉग में भी स्ट्रेट फॉरवर्ड क्वेश्चन आया है, ज्यादा न्यूमेरिकल्स उसमें नहीं आए एज कंपेयर टू द लास्ट ईयर, है ना. पिंकी, डबली लेस, हाँ, मतलब क्वेश्चंस कम आए इसके. अगर बात करें तो बेसिक इलेक्ट्रिकल के 9 to 10 क्वेश्चन आए, राइट. ठीक है. एंड वन मोर थिंग, अगर आपने देखा होगा कंट्रोल सिस्टम के क्वेश्चंस भी आपके इजी आए हैं, है ना. टेल मी, कंट्रोल सिस्टम क्वेश्चन आपने सॉल्व करेंगे. सो नाउ वी विल सॉल्व अ क्वेश्चन फ्रॉम अ सिग्नल्स और आई कैन से मैथमेटिक्स. तो अंकित सर विल कम एंड ही विल सॉल्व अ रिमेनिंग क्वेश्चंस.
थैंक यू सर. Hello everyone. So I have got question from Laplace transform, which is being the part of signals and system, or you can say the advanced electronics. I hope I am audible to all of you. So students, we have got this question, the Laplace transform of periodic waveform. So students, believe that Laplace transform does not exist for periodic signals. So once they are saying for Laplace transform for periodic waveform, means it is semi-periodic. It is either completely on the right side of origin or completely on the left side of origin. So this particular signal is on the right side of origin, and hence this is a semi-periodic signal. So for this semi-periodic signal, we are supposed to find the Laplace transform. So students, we can just formulate this f of t first. So if you just go through this, yes, f of t, so this has got two values. It is having value 1 in the interval 0 to a. We can say that t lying in the interval 0 to a, and minus 1 when t lying in the interval a to 2a. So we have got the value of f of t. Now what else we can do? I'll just write down the formula for Laplace transform of this semi-periodic signal. So Laplace transform of a semi-periodic signal whose repetition time, that is period, is capital T. It is 1 upon 1 minus e to the power minus s capital T, and then we have integration over one period, that is 0 to t, e raised to minus s small t f of t dt. This is the format, and in this format we will be substituting the value of capital T. So here capital T is twice a, and you can see here that a is given as 1, a is given as 1, capital T is twice a, so of course the value of t will be 2. So students, this will be 1 upon 1 minus e to the power minus twice, value of capital T is 2, so twice s. Then this integration is from 0 to t, it means 0 to 2. So 0 to 2 can be splitted into two parts, 0 to 1 and 1 to 2. I'll put a bracket here. Integration from 0 to 1, e raised to minus st as it is, value of f of t is 1 dt. Then in the second part, integration limit is 1 to 2, e raised to minus st as it is, and value of f of t in this interval is minus 1 dt. Okay, so just we need to integrate this. So students, 1 upon 1 minus e to the power minus twice s. Yes, integration of e raised to minus st, e raised to minus st upon minus s. Limits of integration are from 0 to 1. This minus sign is taken out. E raised to minus st upon minus s. And again, the limits of integration are from 1 to 2. Now, see, 1 upon 1 minus e raised to minus twice s. Now apply the limits. Value of t is 1. Value of t is 1. So e raised to minus s upon minus s. Minus sign is taken to the numerator. Lower limits minus, and this minus will become plus. E raised to 0 is 1. So this is 1 by s. Minus minus plus. Value of t is 2. So e raised to minus twice s upon s. Now lower limit. Already this minus minus is made plus. So this minus, and then e raised to minus s by s. So all dear students, when you take s as the LCM, you are getting 1 upon s. Now what else you are getting in the numerator? See, 1, 1 can be written as 1 square. E raised to minus 2s can be written as e raised to minus s whole square. I'll just write down what I want to write here. 1 square minus CL. E raised to minus s and e raised to minus s, it is 2 times e raised to minus s, and e raised to minus 2s can be written as e raised to minus s whole square. So this can be written as 1 minus e raised to minus s whole square. So students, ultimately we will be getting 1 minus e raised to minus s whole square. It means this term is repeated twice. In the denominator, we are getting 1 minus e raised to minus 2s, which is nothing but 1 square minus e raised to minus s whole square. So a square minus b square is a minus b and a plus b. So we can cancel these terms. So what else is with us now? 1 minus e raised to minus s and 1 plus e raised to minus s. So when this particular term is multiplied by e raised to s by 2 in numerator and denominator. E raised to s by 2 in numerator and denominator. What you will get? You will be getting 1 by s. Here you will get e raised to s by 2 minus e raised to minus s by 2 upon e raised to s by 2 plus e raised to minus s by 2, and this is nothing but, this bracket is nothing but hyperbolic tan h s by 2, tan h s by 2. Can I have your response? Tan h s by 2. So tan h s by 2 upon s, tan h s by 2 upon s, option A is the correct answer. Yes. So that's all regarding this question. So now my colleague, my friend Saket Verma sir will be joining, and he will be taking questions from EMFT and communication. Welcome sir.
Thank you, sir. So hello everyone. So we are left with some questions of EMFT and communication. So this time the weightage of EMFT is higher, and we have less question from advanced communication, and that is the good news for all of you, because most of you don't study that advanced communication, because it has very vast syllabus, and that is why we generally left and we only pick the basic part of the advanced communication. So like this time we don't have any question from optical, we have no question from the mobile communication, one question from direct satellite, that is the frequency range, and one question from computer network also. So there are less question. Okay, so yes, so Pinky, you can tell what are the different answers you have got and how many you have corrected. So Pinky, you are from electrical or electronics? I think electronics, huh? So this is the one of the question. I think we have done it. Yes, we have done it. Okay, we have done it. That answer was 0.4, right? So answer was root over 0.4, that we have already done. So let's move into the next question. So this is the question that we have got. The number of quantization level is increased from 4 to 64. The bandwidth required for the transmission of a PCM signal increased by a factor of, because it is asking for increase of factor, increase of bandwidth by which factor. So you have to see bandwidth depends on which particular component. Okay, so in the PCM, okay, so in PCM we know that the bandwidth is given by RB by 2, okay, and we can say that the bandwidth is N into Fs by 2. So the bandwidth is directly proportional to the number of bits, and that is why we say that in the digital communication the bandwidth requirement is more, because when we have number of bits more, then the quantization will become easy and the quantization noise power will be less, and but when we increase the number of bits, the bandwidth will also increase. So here you can see that the quantization levels, this is nothing but the number of bits. If I want to calculate, this is log base to the quantization levels. So the quantization level is 4 here. So we have the 2 bits required. And similarly, when we increased from 4 to 64, this is log base to L2. If I say this is log base to 64, this is nothing but a 6. So you can see that the number of bit is increased by a factor 3. The number of bit, when we increase the quantization level from 4 to 64, the number of bit increased by factor 3. So the bandwidth should also increase by factor 3. But as the options are given like 1 by 3, 1 by 4, 1 by 5, 1 by 6, so obviously it should be actually increased by factor 3. So we should directly say the answer option should be 3, 4, 5, 6 like that. But because in this ESE we have sometimes wrong options or the wrong question, so because it may be, there may be a chance that this question will be removed and the marks will be given to all of you, or that the question will be directly cancelled. And if it does not cancel, then definitely we would have marked as option A. So it is not yeah, so the answer would be option A for this. Okay, means according to option, if I have to mark in the examination, then I would have marked as 1 by 3, but because it is asking for increase of the bandwidth, so it should be actually 3, because when we say 1 by 3, that means it is actually decreasing, right? So satellite communication, the range is 4 to 8 gigahertz. Okay, Pinky, so the 4 to 8 gigahertz, because for uplink frequency we have 4 gigahertz, for downlink frequency we have 6 gigahertz. So actually it ranges from 4 to 8 gigahertz, which is your S band, C band, sorry. C band, the satellite works in the C band, so that is your C band. Now coming to the next question. The range of VSWR. What should be the range of VSWR? Yes, come on, answer this question. What should be the range of VSWR? So we know that the reflection coefficient has the range between -1 to 1. Okay, this is the range of reflection coefficient, and we know that the standing wave ratio is given as 1 plus magnitude of gamma divided by 1 minus magnitude of gamma. So if you substitute this value, you will get 1 to infinite. Okay, that is when you put s equal to 1, sorry, gamma is equal to 1 or -1, you will get infinity, and when you put gamma equal to 0, you will get 1. So the range of the standing wave ratio is between 1 to infinity. So that is very easy question, direct question. That is option C. Yes. Now coming to the next question. Which one of the following mode has the solution of Hz equal to 0 but not Ez equal to 0? So we know that for the transverse electric mode, the electric field exists in the transverse to the direction of propagation. That means if the wave is propagating in the z direction, then the electric field z component cannot exist in case of TE mode. So it will be 0 and Hz will not be 0 in case of TE mode. And in case of TM mode, as the name suggests, transverse magnetic, so the magnetic field will exist only in the perpendicular direction to the direction of propagation. That means it will not exist in the direction of propagation. So if the wave is traveling in the z direction, Hz will not exist and Ez will exist. So Hz will not exist and Ez will exist, so that is your TM mode. And in the TEM mode, that Ez and Hz both will be 0. In the direction of propagation, the electric field and magnetic field does not exist. So that is option C. So in the advanced mobile phone system, which of the following separate channels in the link is or are used? So that directly we can say in the advanced mobile phone systems, we use the TDMA technique, right? So in this particular question, we have the statement question. This is assertion reason question. So in the sampling and the quantization, this sampling and the quantization are not reversible process. So these errors are reversible and it is not possible to produce. So it is wrong statement because it is not reversible process. And the use of digital communication offers flexibility and compatibility in that of the adoption of a common digital format makes it possible for a transmission system to sustain many different sources of information. So that is nothing but the advantage of digital communication. So this is the correct statement and this one is wrong. So we have statement 1 is false and statement 2 is true. Okay. Now coming to the next question. Yes. So this is the question from EMFT and this is nothing but a impedance matching. So what is the right answer for this? For the single stub tuner, an open or short circuit section of a transmission line length D connected in the parallel with the main transmission line. So to match the stub, we use some particular length of the transmission line at some particular distance. So this is correct statement. An open circuit stub radiates some energy at high frequency. So this is also correct statement. And double stub matching allows for the adjustable of the load impedance. So this is also correct. So all the three statements, these first, second, third are correct. So obviously here from the options you can eliminate this and the answer will be option B. So now this is the question from I think digital. So now the Sanjay Rathi sir will come and he will explain the remaining questions of the digital and other subjects.
Thank you, sir. Now we will discuss some questions from digital, some questions from what analog, right guys? So that is the first one. Please give me the answer. What is the answer for this one? Consider the division of dividend x is equal to 0, 1, 0, 0, 0, 0, 0 and the divisor is 0, 1, 1, 0, then the quotient and remainder respectively are. Right? No need to use what digital concept of digital, but simply you can convert it into what decimal equivalent. So what is the decimal equivalent of 0, 1, 0, 0, 0, 0, 0, that is the 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, that is nothing but 32. Okay, and 0, 1, 1, 0, this is nothing but 6. Okay, so 32 divided by what? 6. So how many times? 5 times. So what is the remainder? 2. What is the 5? 5 is represented as 0, 1, 0, 1 and the remainder 2 is represented by 0, 0, 1, 0. 0, 0, 1, 0. The answer is what? A. Are you getting this answer A? Everyone? Okay, Pinky. Now, this is the answer A for this particular question. Okay, then second one. Statement and again, statement, one statement, second statement and these are the options. To read this question, the differential amplifier is set to operate in common mode configuration when the same voltage is applied to both the input terminal. Yes, differential means when we are having the differential amplifier or when we are giving the same signal V1, V1. For example, these two signal are same V1 and V1 means what is the output? AD VD plus AC VC. And what is the VC here? V1 plus V2 by 2. If both are same, let V1 is equal to V, V1 is equal to V2 is also V. So this will become Vs plus Vs divided by what? 2. That is nothing but Vs. Okay. Now, and at the same time, what is the VD? V1 minus V2. It will become 0. So what is the output? AC VC. Means the differential amplifier is set to operate in the common mode configuration when the same voltage is applied to both the terminal. Common mode because the difference output depends upon the difference. Yes, Pinky, that is 32 by 5. Now, right, so this statement is right. The ability of a differential amplifier to accept a common mode signal is defined as figure of merit. No. What is the differential amplifier? Reject the what? Common mode signal. That is what? AC should be equal to 0 ideally. AC should be equal to 0. Output should be proportional to difference of the input. That's why this statement is wrong. So A is correct, B is wrong, C. Statement 1 is true, but statement 1 is true, but statement 2 is what? False. राइट अगर यहाँ रिजेक्ट लिखा होता ना, द एबिलिटी ऑफ अ डिफरेंशियल एम्पलीफायर इज टू रिजेक्ट अ कॉमन मोड सिग्नल, देन इट इज कॉल्ड फिगर ऑफ मेरिट, दैट इज कॉल्ड CMRR, कॉमन मोड रिजेक्शन रेशियो, CMRR, it is called figure of merit. Now next one, okay, next question. Our recombination process in an n-type semiconductor involves the interaction of, it involves the interaction of what, right? And that is, there are different types of recombination processes, but in this process, there will be the recombination of 2 hole and 1 electron. This is a theoretical question, but it is again in the mains they will ask more question on this, and they will ask about the different types of recombination, what about the difference in a tabular form. So 2 holes and 1 electron, and remember when there is a recombination, energy is not given in the form of what, photon, that will balance inside the semiconductor. To get the more detail about this topic, okay, so that is the C, 2 holes and 1 electron. Then okay, next question. The failure of the transistor to respond to the trailing edge of driving pulse is, why there is a failure of the transistor, why it can't perform, right? Then first of all, in any transistor, emitter junction is forward bias, right? When this is a forward bias, large number of, for example, it is a PNP, then PN hole will move from P side to N side in the base region, right? And when the transistor is in saturation, the large number of hole will move from P side to N side. What is the status of hole in N region, that is in base region? That is minority carrier injection. So this is called minority, because the status of hole in this region is what, minority carrier, and that's why this process is called minority carrier injection. Minority carrier injection, right guys? Now when the large number of holes restore here, if suppose we are changing the signal, right, that is the driving pulse is trailing edge, this is the pulse, it is on, and this is, it will make it what, off, but suddenly when we are changing the signal, then what will happen, that there should be a restorage of minority charge carriers, the hole will move from base to what, emitter, then it will take time, and that is the problem. So similar type of problem in what, diode switching time, that is called what, minority carrier storage and what, transition time. So that is the reason the failure of the transistor to respond to trailing edge of driving pulse is saturation charge of excess minority carrier stored in the base. Saturation charge of excess minority carrier stored in the base, guys. So that is the answer. Next one, next question. Okay. By considering the standard notation for depletion MOSFET, the space parameter lambda value is, what is the lambda? Early effect, lambda 1 by VA. And what is the unit of this? Volt negative for MOSFET. This parameter depend upon early voltage. VA is the early voltage, that is the D. D is the answer for this particular question. Okay then. So that is the question on this. Okay. So tell me what about the level, and already sir will come and he will solve some more question on that, right guys? And according to me, number of questions are what same from the last previous year questions and so on. हम लोग पहले ही बोलते हैं, अगर आपको इंजीनियरिंग सर्विसेज एग्जाम की तैयारी करनी है ना, तो प्रीवियस ईयर क्वेश्चन को बहुत अच्छे से तैयार करो. प्रीवियस ईयर क्वेश्चन मतलब लास्ट 20 इयर्स के आप प्रीवियस ईयर क्वेश्चंस को अभी से, जो नए स्टूडेंट है जो 2025 के लिए प्रिपरेशन करना चाह रहे हैं, ओके 2024 2025, तो पूरे लास्ट जितने भी साल के आपके पास प्रीवियस ईयर क्वेश्चंस अवेलेबल हैं उनको अच्छे से देख लीजिए. दूसरा, इट इज नॉट अ क्वालिफाइंग नेचर, मार्क्स विल बी एडेड इन व्हाट, मेरिट लिस्ट. तो इसके पूरे मार्क्स आपके ऐड होने वाले, तो जितने ज्यादा आप मार्क्स लेकर आएंगे इन व्हाट इंजीनियरिंग सर्विसेज प्री एग्जाम, उतने ही आपका मेरिट ऊपर जाएगा. साथ में अभी मेंस का भी एग्जाम होगा इसके बाद, राइट? तो अब आपका ये तो हो गया यहाँ तक क्वेश्चन. अब आएंगे आशु सर और क्वेश्चन डिस्कस करेंगे फ्रॉम नेटवर्क थ्योरी. ओके सर, प्लीज.
Thank you, sir. Thank you. Hello, guys. Hello, guys. I hope everyone is fine there. So let's start with the network theory. Okay. So, okay. So this is the question, and in this question, there is one star network is given, and we need to convert this star into delta. Okay. Star to delta transformation we have to apply. So it's very simple. Okay. Now what I need to do is I need to find this resistance and this resistance and this resistance. So it's very simple. 10, 40, 20. So 10 plus 40, this resistance will be equal to 10 plus 40 plus 400 divided by 20. Okay. So it will become 70. Okay. 70 is in two options. Now let's come to this resistance. So 20 plus 40, 20 plus 40 plus 20 into 40 divide by this one. So this is cancelled. So it will become 140. Okay. Now 140 is not given in any option. So I'm going with 150. Okay. Because no option is matching with this resistance. Now, yes, 140 is given in one more. Na? 70 is also given in this. So there were A, C and D. Three options were there. Only one option is eliminated. No. Even this option was also not eliminated. So let's come to the next. So this resistance came out to be 140. Now 70 and 140 we have calculated, and 70 and 140 is available only in this option. Okay. So answer is Agra. So it's simple. Okay. Let's move to the next question, guys. We don't need to convert. We don't need to calculate this one. Why? Because it's a time waste. We got the final answer, and then let's proceed. So let's come to the next question, guys. Let's come to the next question. And the next question is this. What is the value of number of possible trees in the graph shown in the figure? So the formula for number of possible trees is n raised to the power. Tell me, guys, what is the formula? N raised to the power n minus 2. N raised to the power n minus 2. And n is number of nodes. 1, 2, 3, 4. So actually there are 4 nodes. So 4 raised to the power 2. That is 16. So answer is 16. Answer is Bombay. Let's come to the next question, guys. Okay, so the next question is, for a network shown in the figure, if the switch is closed at t equal to 0, okay, this is RLC network and the switch is closed at t equal to 0. Now the question is, when R by 2L is less than 1 by root LC, which one of the following statement is correct? So actually in the options, he's asking about the nature of the circuit, okay, is it underdamped, overdamped or critically damped? So wherever R, if you look at the denominator of the transfer function of this network, then the denominator will be R plus LS plus 1 by CS. Now it will become LCS square plus RCS plus 1. Okay, take this LC common. So S square plus R by LS plus 1 by LC. Now you can calculate the discriminant and check, using the discriminant you can check the roots of the system and the nature of the system. Okay, now the discriminant will be R by L square minus 4 by LC. Now if it is less than 0, let's take less than 0, then the roots will be complex and the system will be underdamped. So now you can see that R square upon L square is less than 4 by LC, and you take the root. Okay, so it will become R by L less than 2 by root LC for underdamped system. Okay, for complex root, I'm writing for complex root. Now you can see that R by 2L less than 1 by root LC. So this condition is for complex root and the system will be underdamped. So tell me, the roots are complex conjugate and it gives the underdamped response. Okay, so answer is Calcutta. Let's move to the next question, guys. So the next question says, next question says, we have an RLC series circuit with R is equal to 4, R is equal to 4, R is equal to 4 ohm, okay, and we have L and we have C. And L value is 2 Henry and C value is 2 Farad. So now again we can apply the same condition. Now, what type of transient current response is offered by the circuit in when you apply the step input voltage? So again, the previous question is repeated here again. So you can see that R by 2L. If R by 2L is R by 2L, yes, R by 2L was there or something. R by 2L less than 1 by root LC. For underdamped, this was the condition. For critically damped, you have to make it equal. For overdamped, this should be greater than this. Now you can calculate this value R by 2L. Now calculate R is 4 divided by 2L. 2L is again 4 and 1 by root LC. root of L and C. So 2 into 2 is 4. Okay, root L and C. Yes, 2. So now you can see that this is 1 and this is 1 by 2. And 1 is greater than 1 by 2. Is it clear, guys? So you can see that this system is overdamped. So answer is Delhi. Okay, let's move to the next question, guys. Let's move to the next question. These were very easy question. I hope you are enjoying. Okay, let's come to the next question. Network theory was very easy. Let's come to the next question, guys. So the next question is yes. Now in this question, it is given that what is the value of V naught T? What is the value of V naught T for the circuit shown in the figure, assuming 0 initial condition? Okay, we need to calculate V naught T. Now, I'm not going to calculate the entire expression. What I'm going to do is, I'm just going to apply the Laplace, because there is no other choice. If you are writing the initial voltage and steady state voltage, if you are looking from that, you'll get many options. Okay, so the problem is, look at the options now. In options, there is e to the power minus t, e to the power minus t, e to the power minus 2t, minus 2t, e to the power minus t, minus 2t, minus 2t, minus t. It means if somehow you can analyze the power, then you can get the answer. Okay, so how to analyze the power? Which power will come in exponential term? So for that, what we can do is we can apply the Laplace transform and look at the pole location. Okay, so if I apply the Laplace transform, the circuit will look like this. In the Laplace domain, it will be 4 by S, and it will become a current source of value 10 by S, and it will be S. It will be S, and it will be 4. Okay, it will be 4 ohm. Now you can see that there is a current division. You can apply the current division. So if you apply the current division, 10 by S into, it will become 4 by S divided by 4 by S plus 4. Okay, now you can simplify this. This will become 40 by S square, and this is the current in this direction. Okay, 40 by S square into S divided by S square plus 4S plus 4. It's very interesting now. Now you can see that this is the current in this path. Multiply by 4 will be the voltage across this resistance. Now if you look at this carefully, this 1S is gone. It will become whole square of S plus 2. Okay, and if you take the Laplace inverse, you will always get e to the power minus 2t. There is no term which will have e to the power minus t. Okay, so it means this is wrong because it has e to the power minus t term, and this is wrong because it has e to the power minus t term. Now this will be wrong because it has e to the power minus t answer. Okay, so the answer is Bombay. You don't need to calculate the entire expression. Okay, let's move to the next question, guys. Let's move to the next question. So the next question is yes, the next question is, now in this question we have to find the Laplace transform of this function, and it is 1, it is 2, 3, 4. Now what we can do is we can assume that this is ft or maybe zt. Let's call it zt. If it is zt, this function will be g of t minus 2, and the next function will be g of t minus 4. So it's a shift. You can apply the shifting property. The Laplace transform. So you can see that ft is equal to zt plus g of t minus 2 plus g of t minus 4, okay, up to infinity. Okay, you can write this ft function like this. Now if you take the Laplace of gt is gs, 1 plus e to the power minus 2s plus e to the power minus 4s up to infinity. Okay, up to infinity. Now you can take the gp. Okay, it will become gp, so you can take the sum a divided by 1 minus common ratio. Now what is the Laplace gs? Gs is this function. Gs is this function. Okay, now you can write this function in terms of ut. Okay, so it will become gt will be equal to ut minus 2u of t minus 1 plus u of t minus 2. I hope it is clear. ut minus 2u of t minus 1 plus u of t minus 2. Now if you take the Laplace transform, then gs will be equal to 1 by s, you can take common, it will become 1 minus 2 e to the power minus s plus e to the power minus 2s, and it will be 1 by s 1 minus e to the power minus s whole square. So this is my gs. Now you can multiply this factor with gs, so it will become 1 by s into 1 minus e to the power minus s whole square divided by this term, and I can break this term in two factor, e to the power minus s into 1 plus e to the power minus s. I hope it is clear. One power is gone, so it will become 1 by s into 1 minus e to the power minus s divided by 1 plus e to the power minus s. Now what we can do is we can make it symmetric by taking common of e to the power minus s by 2. If you take the power e to the power minus s by 2 common from the numerator and denominator, then it will become 1 by s into, let me write it here, 1 by s into It will become e to the power minus e to the power s by 2 minus s by 2 minus e to the power minus s by 2 divide by, here also you can take e to the power minus s by 2 common, so it will become e to the power s by 2 plus e to the power minus s by 2. Okay, now this is 10 hyperbolic function, 1 by s 10 hyperbolic s by 2. So answer is Agra. Answer is Agra. Okay, 1 by s 10 hyperbolic s by 2. I hope it is clear. So this was very simple question. Let's move to the next question, guys. So the next question is, okay, so let's move to the next question. Yes, next question is again very simple. Now look at the answers first. If you look at this carefully, you can eliminate the answer. Don't try to calculate it. Okay, now the question says the network shown in the figure, the switch is moved from A to B. Previously it was at A, and it was at A for long time. It means it was working under steady state. If it is working under steady state, it means the capacitor was charged, and capacitor will behave like open circuit. So if you open circuit the capacitor, what will be the voltage across the capacitor? 6 divided by 6. 1 ampere will flow in this path, 1 into 2. So you will get 2 volt. So the capacitor initial voltage was 2 volt. Okay, capacitor is charged at 2 volt. It means at t equal to 0, you are moving this to this point. Okay, it means at t equal to 0, this voltage has to be 2 volt. So this voltage should also be at 2 volt. Now look, in which option you are getting 2 volt at t equal to 0? Only A option and D option. Now if you look at the A and D option, the time constant is different. Okay, so now the next point is time constant. Let's calculate the time constant. How to calculate the time constant is very simple. Time constant is equal to RTH into C. Okay, C value is 1 farad. Now I need to calculate RTH. RTH between these 2 points. So the RTH will be, this is 6 ohm in parallel with 2. So 6 into 2 divided by 8. So it came out to be 3 by 2. So time constant is 3 by 2. Answer is Agra. I hope it is clear. You don't need to devote some time on that because you don't need that entire expression. I hope it is clear. Let's move to the next question, guys. So the next question is, let's move to the next question. Yes, the next question is, what I need to do is, what is the voltage transfer function of 2-port network shown there? So I need to calculate the transfer function V2S upon V1S. So what you need to do is you just calculate this current in Laplace domain. So it is V1S divided by R plus 1 by CS. Okay, this is the current multiplied by 1 by CS. This is by V2S. Now you can calculate V2S by V1S. So V2S divided by V1S will be equal to, tell me guys, what is this value? This value came out to be 1 by RCS plus 1. Okay, so the answer is Bombay. Answer is Bombay. I hope it is clear. Let's move to the next question, guys. Let's move to the next question. So the next question is, yes, Z parameters are provided to you, and now I need to calculate the H parameters. Now you have to be careful. Don't devote much time on this type of question, because you don't need to calculate entire H parameters, okay? Because it will consume time. So that's why what we are going to do is first write the Z parameter equation. First, because the Z parameters are provided to you, so we will write the Z parameter equation. V1 equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. Okay, now I have written the Z parameter, but I need to calculate the hybrid parameter. Now we know that in hybrid parameter we write I1 and V2 in terms of, tell me guys, in terms of I1 and V1 and I2 in terms of I1 and V2. In H parameter we write it like this. Now if you look at this carefully, from this expression, from this equation, you can calculate I2. So if you calculate I2, it will be minus 10 by 11 I1 plus V2 by 11. Is it clear, guys? So you can see that the I2 is in, we have found I2 in terms of I1 and V2. So the coefficient of I1 is minus 10 by 11 and V2 is 1 by 11. So it means H21 has to be minus 10 by 11 and H22 has to be 1 by 11. Now look at this. H21 minus 10 by 11 and H11 is 1 by 11. So C option may be correct. Let's come to the A option. In A option also, H21 is minus 10 by 11. So A option is also correct. It might be, but this is wrong. This is wrong. Why? Because look at this, 12 by 11, 12 by 11. So we have eliminated 2 options. Now we have to put this equation, because now we have to calculate V1 in terms of I1 and V2. Now this equation is V1 in terms of I1 and I2. So in place of I2, you can put this value. If you put this value, then coefficient of I1 will change, but the coefficient of V2 will not change. If you put this value, you can see that V1 will be equal to 2I1 minus 10 by 11 I1 plus 1 by 11 V2. It means you can see that the coefficient of V2 remains at 1 by 11. and coefficient of V2 will be H22. So H22 has to be 1 by 11. In which option H22 is 1 by 11? There were two options, A and C. Here you can see that H22 was 10 by 11, but here it is 1 by 11. So answer is Agra. You don't need to calculate the entire answer, okay? Just be fast, be quick, okay? Let's come to the next question. Let's come to the next question. And the next question is this. Now, what is the lattice equivalent network parameter, ZA and ZB? So the lattice equivalent I need to calculate. And if you know the lattice equivalent, so the lattice equivalent will look like this. Okay, it will look like this. The lattice equivalent will look like this is ZA, this is ZA, this is ZB, and this is ZB. Okay, now I need to calculate ZA and ZB. ZA and ZB. Now, what is the formula for ZA and ZB? Using two-port network, you can calculate ZA and ZB. And if I tell you the formula for ZA, it will be Z11 minus Z12, and ZB will be equal to Z22 plus Z21. Z22 plus Z21. Okay, so these are the formulas. Z22 plus Z12, I suppose. Okay, or maybe Z21. I think it's Z21. Okay, let's try to calculate, and let's try to calculate ZA and ZB. How to calculate ZA and ZB, guys? First, I need to calculate the Z parameter of this. How to calculate Z parameters? For this type of network, Y parameter is very simple. Okay, so first let's calculate the Y parameter. We know that Y11 will be equal to this is minus of Y21. Or minus of Y12. Okay, so now you can see that it will be minus 1 by 5. It will be minus 1 by 5. Is it clear, guys? Y21 or Y12 can be calculated from this. Now we know that this value has to be Y11 plus Y12. Okay, so Y12 is minus 1 by 5. You can take this minus 1 by 5 on this side, and it will become 3 by 10. Okay, so it is 3 by 10, and this is again 3 by 10. So we have calculated Y parameter. Now you can take the inverse and calculate the Z parameter. The inverse will be 9 by 100 plus 1 by 25. Okay, so it will be 100 will be the LCM, and is it correct? 9 by, wait a minute, 1 by 10 plus 1 by 5, no? So LCM was 10, so 1 plus 2, so 3 by 10. I think this is correct. So now let's calculate this value. So it will be 100 will be the LCM, 9 plus 4, so it will become 13 by 100. Is it clear, guys? 13 by 100. Let me check because we have already calculated. Yes, this is correct, guys. Up to this point, everything is fine. Now, what I need to do is I need to take the inverse. When you take the inverse, then what you do is you invert these values. Okay, 3 by 10, and change the sign of these quantities. So it will become 1 by 5 and 1 by 5, and divide by this determinant. Okay, so it will become 100 by 13. It will become 100 by 13. Is it clear, guys? Because I think there is a problem. This has to be minus. Okay, this has to be minus. Okay, now it should be minus. So it will become 5. It will become 5 upon 100. So it will become 1 by 20. Okay, so the determinant is 1 by 20. So now I have to replace it with inverse of 1 by 20. Inverse of 1 by 20 is 20. If you take it inside, then the Z parameter you can calculate. So it will become 6. Here you have 4. Now here you have 4, and here you have 6. So we have calculated Z parameter. Okay.
नहीं परफेक्ट है. और एक और आपको मैंने क्लास में एक और मेथड भी पढ़ाया था, दैट इज व्हाट कॉल्ड बार्लेट्स बाइसेक्शन थ्योरम.
Okay. Yes. Using that theorem also.
Divide it into two parts and then get the open circuit resistance, that is the ZB. When it is open circuit, it is a 10 ohm, and when we are making it for short circuit, 10 parallel with the 5, right? And you will get the value.
Even you can see that.
Yes.
When you open circuit it, then ZA and ZB and ZA and ZB. So the equivalent has to be ZA plus ZB by 2. Okay. ZA plus ZB by 2. So now from here also, this is 15 in parallel with 10. That has to be ZA plus ZB by 2. Okay. From there also you can compare. Okay. You can calculate ZA and ZB. But I found the Z parameters. Once you get the Z parameter, you can put these values and you will get the answer. Okay. So the answer will be Agra. ZA will be 6 minus 4, that is 2, and you can easily calculate for ZB. Okay. Let's come to the next question, guys. So the next question is, let's come to the next question. So the next question is, yes, this is the question. Now in this question, the Thevenin equivalent impedance. Okay, so it's very simple. Only the calculation part is there. So what you can do is you can sort this sort this voltage source, you can sort this voltage source, and you can take the parallel of these two impedances and in series with 10. Okay, so it will become 10 plus 6 plus J2 into minus J4 divided by 6 minus J2. So it's very easy peasy. Okay, now it will be 10 into 10 plus, you can see that it is minus J24 and plus 8. Okay, divided by 6 minus J2. If you simplify it, answer will be, let me tell you the answer because you can simplify it at your own. Answer is Agra. Okay, it's very simple. Let's come to the next question. Let's move to the next question. So the next question will be, wait a minute. Yes, next question. Again, it's a very simple question. Now, what is the value of the voltage between A and B? This point is A, this point is B. We have to calculate the voltage difference between them. We know that in this branch there is no current. According to KCL, you can see that this current has to be 0. So this voltage has to be 0. Now, the current will flow in this loop individually and the current will flow in this loop individually. Now, what is the current in this loop? 30 divided by 30. 30 divided by 30 is 1 ampere. So 1 ampere will flow here and 1 ampere will flow here. Okay. Now, if you know the current value, then what you can do is you can calculate the voltage difference across this resistance. It has to be 15 volt. Okay. This has to be 15 volt and this has to be 10 volt. Now you start from A. You start from A. This is VA. VA minus 15 minus 5. This voltage is 0. Minus 20 plus 10 is equal to VB. So from here, VA minus VB will be equal to, you can calculate this value. So it will be 30 volt. Is it clear, guys? Answer is Bombay. Answer is Bombay. So this was again easy peasy. Okay, let's move to the next question. So the next question is, let's move to the next question. Yes, next question is from nodal. I need to calculate VA. Okay, so if you want to calculate the node voltage VA, actually the answer should be node defined. Okay, let me tell you guys. Because there is no reference point. If there is no reference point, you can't calculate VA. Okay, because there is no reference point. We don't know the reference point. That's why you can't calculate the value of VA. But options are given. So you have to, I mean, there is no challenge option. I mean, you can't challenge it. Otherwise, if this question were in gate, we must have challenged this question. Okay. But now, since the options are provided to us, so what we will do, we will assume that this is ground. And with respect to ground, we need to calculate the voltage VA. So what we are going to do is we are going to write the coefficient of VA. The coefficient of VA is 1 by 5. If you know the direct method of nodal, 1 by 5 plus 1 by 2 plus 1 by 3. 1 by 2 plus 1 by 3. That is equal to entering current. Entering current is 10 ampere from this side plus 10 from this side, 10 from this side plus 10 by 3 on this side. Okay. So we have written the direct nodal equation. Now from this equation, you can see that the LCM will be 30 here. So it will be 6 plus 15 plus 10 and that is equal to LCM is 3 here. So 60 plus 10. Okay. Now this 3 will cancel with 10. So VA came out to be 70 into 10, that is 700 divided by what is this value? 31. And 700 divided by 31 is answer Bombay. Okay, this came out to be Bombay, I suppose. Let me check. I have done the calculation, I think. So wait a minute, let me check the value. Yes, answer is Bombay. Let's come to the next question, guys. Let's come to the next question. And the next question is this on your screen. What is the value of resistance RL in the circuit shown in the figure to deliver the maximum power from the source to load? Okay, we want to deliver the maximum power to this load. So if you want to maximize the power to this load, then this RL has to be equal to RTH. So we have to calculate the Thevenin resistance. For calculating the Thevenin resistance, you have to deactivate it. So let's deactivate it and let's call it A and let's call it B. Okay, so from A, you can see that from A there are two paths. Okay, one path has 10 ohm, one path has 30 ohm. Okay, 10 ohm and 30 ohm. There are two paths. Okay, one path is 10 ohm and the other path is 30 ohm, and both the points are connected. Both the points are sorted here. Now from this point again, two resistance will come to B. Okay, one is 20 ohm, one is 20 ohm and one is 40 ohm. Okay, one is 40 ohm and this point is B. Now what we can do is we can take the parallel of these two resistance and parallel of these two resistance and then take them series. So the answer will be equal to, let's take the parallel. So it will be 300 by 40 plus it will be 800 by 60. Okay, now it will be 7.5 plus 7.5 plus this is cancelled. This will be 40 by 3. Okay. 40 by 3, I suppose. Okay. 40 by 3 is 13.33. Okay. 13.3 plus 7. So I think it will become so it will become 20.83. Okay. So answer is Bombay. Let's come to the next question, guys. Let's come to the next question. And the next question is, next question on your screen is this question. I think this is the last question from network theory. Okay, so in this question you can see that from the impedance triangle of an RL series circuit fed with single phase voltage, what is the value of power factor? Power factor is very simple. Power factor is cos phi. You can see that this is R, this is X, this is Z. Okay, so power factor will be equal to cos phi. Cos phi is equal to R by Z base upon hypotenuse. Okay, so you can see that cos phi is R upon Z. Simple. You can take that R upon Z. So where is R upon Z? R upon Z is this. Okay, so we can calculate a power factor easily. Answer is Calcutta. I hope you enjoyed this session, guys, and don't forget to share this session. Don't forget to like this session. And we have I think we have discussed almost every question. So you can check your answers and you can check how many questions you have corrected, and I mean, what is your I mean, what's your view on this exam? Please tell us in the comment section. And पेपर ज़्यादा मुश्किल नहीं लगा मुझे नेटवर्क का तो, and it was not lengthy though. Lengthy भी नहीं था network theory, but you have to be smart while solving the questions. Okay, so I think. Okay, so the PDF for this for the answers of these questions will be provided by night, by maybe tonight itself. So it will be shared with you, and you can go in the link and in the link also we'll provide the PDF. Okay, so that's all for today's session, guys. I hope you enjoyed, and don't forget to like, subscribe, and share this session. Okay, so thank you. Take care. Bye.